Do it to me!
Alright then, I know. It's a little boring while I get it loaded up. I'm sorry. I'm so sorry. I just want to make sure I can tell everyone that it's happening. Alright, so for those rolling in, welcome. Welcome, welcome, welcome. Okay, you're lovely. Oh god, why does my tongue keep doing that? I'm sorry, I'm terrible. Just drinking too much. Alright. So, welcome everyone. Cody, you're, well, friendly neighborhood DeFi degen, and we are here to look at the launch for POTUS coin. So we have just had a contract drop. Contract is out, the launch is occurring, and we are going to go through the actual deployment, the structure, transactions, and the contract itself. So, going to give everyone a little bit of time to roll in. Yes, the sale is live right now. I understand folks might want to delay a little bit as we dig into that. So, while I will go through the tokenomics, I hope that everyone has already read this themselves. If you got any intent of buying this, you should read this yourself. Link in the description and on the channel. Again, it's that president.finance. So, head over to president.finance, make sure you always read your tokenomics. But, in this case, we are going to jump right into the contract itself. Now, this is a brand fresh new contract, so, unless my decompile of the bytecode went through earlier, or somebody else has asked for it, we are getting to pull that down for the very first time. Alright, goodness. Everything seems to be pretty goddamn busy, doesn't it? Alright, here we go. Got that loaded up. Got our contract in place. Ah, cute. We got Flare in the comments. We've got nice, cute little Flare. Haha, there we are. So, folks, for anyone that isn't aware of what I'm doing, if you'd like to know how to go find this yourself, how to read this, I understand it's code. It can be intimidating. It looks all weird. There's all this strange punctuation in places and odd words that are being used. But trust me, you can at least understand enough to spot suspicious activity. To see and to be able to spot when, well, there doesn't seem to be anything wrong. So I'm doing this channel as an encouragement to all the DeFi degens out there. We're doing this because there's no regulation. We're doing this because no one's watching over our shoulders. We can do whatever we want in this space. So let's make sure that we take that liberty, that freedom, and use it responsibly. Make sure you're actually checking what you're investing in. Make sure you're vetting the code. If you don't know how to code, learn the goddamn code. You don't have to become an expert. You don't have to become very competent. But at the very least, much like any business person learning to read a business perspective, much like any trader learning what trend analysis is, learning what a valuated average price, what a market cap, what various indexes are, got to be able to explain what an inverse or correlated fund is. In these cases, it's just your due diligence. If you want to make those fat gains, you got to be able to do the work. And you got to be able to do the work on your own without waiting for anyone. So, here I am, your friendly DeFi degen dog, going to be going through the code right now with you, explaining a bit of what's happening. Now, in these cases, devs are usually busy. So they're usually busy handling the launch, taking care of things. We understand. They might either be doing community management, they might be trying to actually handle the launch of code, make sure things are executing right. So hopefully we can get someone in for an interview. Feel free to hop over to their Discord. You can find all the information again at president.finance. Be able to ask them. Feel free to push them to see if they can make some time to come in for an interview. We'll get a Zoom set up, bring them on the call. But in the meantime, we're going to take a look at the code for this project, see if we see any horrible bugs, see if we see any scams. I am going to be fair. For small projects like this, we understand that they just cannot operate the same as some of the big boys. Setting up some of that infrastructure, setting up some of the security, being able to pre-fund with various liquidity, that's just not something we can expect our small game pushers to really provide for us. It's understandable. On top of that, we want to play a little fast and loose. We want to get shit done. So, with that, and the fact that we have to consider that a lot of these are like initial round of angel investment, you know? It's not so much like Bitcoin where you're buying a currency and holding it to go up in value. You're more investing in the idea of what this project is, what you think this will become. The intent of any good DeFi project like this, where the idea is that there is some tokenomics involved around staking. Either you should be identifying exactly what the profit scheme, how they're going to get you that money on those tokenomics through that first round of funding, or a clear description and message of what the intent of these tokens is going to be. Now this one seems to be a bit of a gamified investment scheme, encouraging hodling. We'll be going through the tokenomics in detail as we go through the code, point out points or bring up points that are relevant. But again, main point here is that this seems to be a scheme in and of itself where the intent is to profit while staking. This could go into something bigger, obviously. Something can always get popular and people can decide to do a second round, to do a migration and keep going, all kinds of stuff. But it looks like here, this one is intended to get you profit right now. Now, in this case, when going through the code, we got to understand a little bit about how it's put together. So, if you don't know how code works at all, or anything at all, I'd recommend take a look over at DApp University. They are a solid site, fantastic channel here on YouTube. They'll give you information on, well, how to actually code this stuff, if you'd like to get involved. If not, at least follow along. I'll be trying to explain what some of this stuff means as we go through, but I'd like to give people a quick answer on how good it is now. So, as I'm digging in, if you like what I'm doing, hit the like button, subscribe. I am not affiliated with the team. I am not being compensated by them. I am working for tips and donations, super chats, and general recognition. I can use this as a nice way to get a lead on some things, but I do not initially invest in any of the projects that I am reviewing. I want to maintain no conflict of interest, so I am giving you the information. I am letting you decide. I'm not your financial advisor. I am not giving you a professional assessment. I am just a DeFi degen dog that knows how to code and wants to goob about code with people. At the end, I'll tell you if I would invest, but that's merely a recommendation what I would do if I was already up to my friggin' eyeballs in weird off-the-wall projects. This whole elastic finance thing is insane, and I am loving it. But it takes a long time to pay off. So, for those that need fast gains right now, that you want to become a new Bitcoin millionaire, get that moonshot, feel so good, buy the Lambo, and then be able to play around like the big boys, you're going to have to look at the code. We're going to have to dig in to see if this is the one. Now, we can kind of go past some of the beginning parts. We'll be needing to check this. The due diligence should always be to confirm every line of code. Even though we can be looking here and see, hey, it's an interface. It's an IERC20. Cool. That means it's probably got all the IERC20 tokens. Well, in fact, features. That could be true, but we'd like to be absolutely sure that some shenanigans haven't been slipped in here. That's another important point. It's lovely to be able to look at the GitHub. I see other channels talking about being able to look at the GitHub, check the commits, check the size of the commits, the notes and comments that are left in there to see how the project's developing. That's useful if you can get a bead on a project early. In fact, I am considering doing an upcoming stream on how to search on GitHub to try to find contracts like this. If they're not private and they're in work in their public repo, you might be able to get a bead on that coin before the team has even launched their social media. Now, here, and I'll also go through Gitcoin and how you can find some nice projects there, even contribute to them. But right now, I want to point out that what I'm doing here, I've gone to Etherscan. Etherscan.io, that lovely site, probably all of you already know. If you are a new baby, if you have an empty bag and you're looking for that first hodl, not a problem. Understand you might not know about some of the tools. We'll take a look over at Bloxy in just a second here, but this one, Etherscan.io, tried, true tool. Everyone's been using it for a long time. This gets you information about addresses and contract hashes. Transaction hashes. The contract, that address right here, is the one managing the President Finance. Alright? You can find some nice information here about how it's put together. So things like where the contract creator came from. So you can see right there, there's the address the contract was deployed from. So if you get a rug pull and you're ever wondering what the hell's going on, you can always start following through and find that trail. You may not be happy that it leads to just a wallet address you can't tie to a person, but at the very least, you can do some investigation. Right now, though, what I've done is gone to that contract, made sure, see, if you have the coin contract, you're going to make sure that you actually go to the contract, not the coin listing. And on there, you're going to find this little tab, contract. When you click it, you should see some code, at least if it's an established long-running project. If it is brand fresh, baby new, you're going to see this little decompile bytecode button. Just click that, click submit, let it finish, reload the page, and off you go. It's done usually by the time it takes to reload the page. Because what we're looking at here when we say decompile is quite literally Etherscan has gone out. They have pulled the compiled code that has been written to the blockchain, the thing that has made the money smarter and how it operates, has now been pulled off, decompiled, so it's been reversed from the stuff that the computer understands, and it's been put it back into a form that humans can read, and presenting this to us. So as I was saying, as nice as it is to look through GitHub, to be able to find those good prospects, get in on an early project, be able to review the code, the commit, the comments there, to be clear, you have no guarantee that what is in GitHub has actually been deployed to the blockchain. Until we get nice, secure integrations, a healthy ecosystem in support applications around this, like up until we have something like, say, an Ethereum deployment plugin for Jenkins that will handle all of this automatically, and we can know exactly where it came from with verified signatures. Unfortunately, the best we have right now is the contract it came from. So we don't actually know when we look at a contract whether or not this is what is in a GitHub or what's the fucking GitHub's really the only big one I know of. GitLab, thank you. GitLab before all of that. In this case, we have our code. So, President Finance, digging into what is actually coming off the blockchain. Fuck GitLab, fuck GitHub, fuck whatever the team may say, all due respect. I love these guys for making us so fucking rich and providing such a great value, but I am not going to trust a DeFi degen as far as I can fucking throw them. I know what we're goddamn like. So, looking at the code from the blockchain, we can breeze past some of this initial part. We will want to look through this, as I said, to make sure no little shenanigans have been pulled. But, for the most part, things like interface, that's defining, well, standards in Ethereum. Stuff that is just part of the protocol, part of the Solidity language, and setting it all up. When you see something like library, especially this safe math, an incredibly common, you're going to find this in pretty much every contract. It's almost a requirement. In fact, at this point, I would be worried if I came across a contract that wasn't using safe math. It's kind of that critical. So in here, this is just a nice library, as it's termed, in code. Again, for those of you that are aware and know how to do this, patience, I'm going through some of the basics so folks that are reviewing this and don't know how to code, don't know how to read this, can at least understand generally what we're looking at, hopefully get some of the skills to be able to read it like we are, And if you know how to code, then you should be reading it too, and let me know. I am happy to get co-hosts on. Now, here, safe math. Basically, some code that people can reuse, again, commonly used, spread around everywhere, reliably retrieved, that's just doing some basic work to handle some math. As you can see, it's doing it in nice, safe ways so that we can minimize the chance for errors, minimize the chance that somebody gets something wrong, you know, they don't fat finger something or whatever. In other cases, we're going to have inclusions of more fundamental components. So in this case, this is a library that handles address. That, you might be thinking, wait a minute, I know addresses. My wallet has an address. Contracts have an address. That is right. This is what is helping define that. Now, it isn't the thing that defines it, but as you can see, it does have some nice helper functions to be able to, well, provide information about, well, a particular address. In this case, this thing is wanting to go look up things about addresses, get information from the blockchain about that address. So to be clear, this typically, as you can see from isContract, is not really intended for the outside world to query the contract. It can, but in these cases, one, you can see that this is marked internal. That means that this is only intended to be called from inside the contract. Whenever you see this internal on something marked as a function like this, so function is contract, that's the name of what this operation is called, and then address, account, this is the variables or the parameters that are being passed in to, well, get this thing to work. Because you can see internally, we have a case where in the code, some operation is being completed with that account. I'll get to that in a second. But to be clear, when you see something like this internal, that means that it cannot be called from outside the contract. Quite literally, only the contract can call it. That may seem a little weird. That's because as coders, this stuff can get weird, it can get complicated, it can kind of spaghetti around and be a little hard to keep track of. So we usually like to break the operations down as small as possible and then package them in these functions. And then we call the various functions in order elsewhere in code to get things done. Pardon me. This is also a way that if somebody writes something that people would like to reuse, well, like right here, they can just package up this logic and we can just include it in our code. So, stuff like that, useful. We will want to get to that, but I know what people really want to do is start digging down into how this thing itself actually works. So again, I'm just kind of breezing past some of the basics, library, address. It's kind of a common thing to have structures like this. We will take a look at these functions and what they do, but because they call internal or marked as internal calls, meaning only the contract can call it inside itself as part of its operation, we don't need to get into it right now, because what I find is the best way to review code is go look for what are termed the entry points. The places where the outside world will engage with the contract to get it to do something or get information out of it. Then you can follow the code through to see what it actually does. So, in here, I'm going to breeze kind of pass through that. Same thing, we got a library for safe ERC2, kind of like safe math, just has some common implementations on how to interact with ERC20 tokens. And so in this case, don't have to write it yourself, don't have to maintain this, less chance. This is actually a good sign that a lot of libraries are being used. That means the developer is either making a good point of maintaining libraries for themselves. I'm saying in general the usage of libraries. They're making either a good habit of maintaining libraries themselves so they can reuse code and therefore not have to run the risk of introducing errors. Because if it worked before and you reuse it again to do the same thing, you got a reasonable expectation that it should work fine. Or they're finding existing code online that, again, you have a reasonable expectation based on how much it's been used that this thing, well, will work fine. So, again, kind of moving past there, we've got contract ownable. Contract ownable is, well, typically a definition of, well, how a contract can be structured. As you can see, it's saying it is of a contract. This is referring to a type or an object here. Solidity is like a lot of modern languages, kind of like JavaScript in the sense that it is a object-oriented language. We structure data structures like this, things that we want to model in the code. Oh, pardon. There we are. Things that we want to model in the code as these sort of objects that we put together. All right. Now, from here, we can continue on. Because again, that was the contract, or library safe ERC20. This is the contract ownable. This is again just a definition of common operations that a ownable contract should have. So they're just reusing that. We can continue. Well, again, we'll come back to that, but we want to get down to the real guts of the contract here and where that's happening. Again, we have here this definition of contract ERC20, and this is where we start to see some of the actual implementation. Now, again, this is somewhat basic boilerplate. This is standard stuff that you find in a contract. We will come back to it, but again, part of the reason why I'm just going past this is all reusable code that the dev has either developed, and I'm saying either because these are all the scenarios where it might show up for the most part. Either the dev has developed this sort of thing themselves, and thus is maintaining it responsibly in a proper separation of concerns, as it's termed, to make it easier to work with, or they're reusing proven battle-tested code that's already worked in other contracts in the field. So again, that's not the start of this actual contract. That's standard stuff that pretty much any contract needs to have. All right. The President Finance says that they'll be announcing details on the sale at any moment. That was at 6:42 p.m., so about 10 minutes ago, roughly. It will be around 12 hours from now, they say. Also, reward structure for inviting competition. All right, sweet. So, if you are hearing this, spread the word. Send the links out. Let people know. We have the address out. We have the project up. The sale will be live in about 12 hours. So you guys are getting a 12-hour lead time on this. That's nice. I get some time to discuss, to play around, because now people aren't waiting to buy that. Because I know, I get it in the chat. People are screaming, just get to the code already. I want to know if I can buy this thing. I want my moonshot. But at least we got some time. I'm not going to fill the whole 12 hours, but at least it gives us some more time. Alright, so let's sit back, have a nice cigarette, get ourselves a good drink, and dig into what POTUS does. So, this is where we get the beginning of what makes this thing special. It is Elected POTUS Contract. That's just a name inside the code here. That is an ownable, alright, standard contract structure. One point I am absolutely loving here, and thank you so much, devs. Comments. This is so helpful. One, it is an indication that the developers are taking their jobs goddamn seriously. It is also an indication that this is not a slapdash project, that they have taken the time to actually write this. People reusing code is fine. I got no problem here. I work in open source. I mostly work in trad finance, but I'm fine with reusing code. I'm an old hand at reusing code. My entire goddamn career has been built on reusing code. I don't have a problem there. But when you come across a structure like this, where you have nice, unique names, you've got good, well-structured comments like that, because that's what... Oh, Jesus fucking Christ. Why do you keep bouncing like that? I hate you. When you got nice structured comments like this that are trying to explain exactly what the intent is, so you don't have to be absolutely sure of what every single variable is, they're kind of helping you out and guiding you along. This is done so the developers can better maintain the code over time, so that later on, if they expand, bring on more team members, if they need to come back to code that's been working just fine and they haven't had to touch it for a year, they may not remember what the hell's going on in there. And so they put the comments in like this. You can tell they're the ones marked with the / like that. You see the double /, that's not something that's not code that's actually going to get run. That's something the compiler is going to ignore. That's something the ETH VM is going to ignore. And this is just for the humans. It's for the humans to understand what is going on. Very, very nice that they're there. The way they're written out here, what I'm seeing in the description, how they're structured, this gives me a good indication the dev actually does intend on maintaining this. Or at the very least, put some real care into putting this thing together. So, good job, guys. I love this. I wish more of my team members, employees, and interns would do this. You have no idea how bad the code reviews and postmortems and everything can get when somebody pulls up code and there's not a single goddamn comment anywhere. All right, so digging into this, we can see it's saying that it's going to use safe math. Cool. It's making use of that safe math up there. It's going to be using it for a particular data type. That's just a way to indicate what type of data, some field or variable or property. They're all kind of the same name, depends on which language you're in and who you're talking to, kind of. All pretty much the same thing. But this is saying just what type that is. In this case, the uint256 is saying that's going to be a very large integer value. No floating point and no signing. That's what the u means. So it is not positive or negative. Now, it's also going to be using safe ERC20 from iERC20. All right, good. We got our reference here. So essentially, any time that this elected POTUS contract is going to have any use of the uint256 or any of the standard functions that are defined in safe ERC20, then it'll go up to that code that we saw up there. So we'll take a look at that in a second when it becomes relevant, when we find those calls in here. All right, so down here we are seeing that there is a info for each user. Okay, so this struct, it's different somewhat. I mean, it's still an object, but it's different from the contract. See, the contract is a particular type. Ownable is a specific type of contract. So basically we're saying, all right, I got a data structure that is a contract. That's going to contain a bunch of code, some logic to execute, and some variables. I've given it a name, and I've said it's inheriting or taking on all this stuff from ownable. So that thing that we saw up there, we're saying POTUS, or elected POTUS is saying, okay, I got all this stuff down here that's unique to me. I also have all this stuff that's up there that you just saw. That's also part of me. Then it's also saying, okay, anywhere you see the uint256, go look at safe math to figure out how to use that. Same thing with anytime you want to be using iERC20, go look at safe ERC20. In here, it has a data structure that is typed or described as user info. It has amount and reward debt. And unlike so many other projects where I have to read through the code and try to decipher what they're actually doing and what the hell things are intended to mean and whether or not it matches up to the tokenomics, these guys have given me comments, so it's right here. They just say it. How many LP tokens the user has provided. Fantastic. So they've got it right there that when you stake, your stake is going to be tracked in the contract with user info. It is going to be keeping track of how much you've been deposited. It is also going to be keeping track of a reward debt. Reward debt, see explanation below. Oh, alright. So this one's going to be a little complicated. In the comment, let me see if I can make that a little bigger and easier for people to read. Does that work? Yeah, there we go. That should be nice for people, I think. Ah! Too small. Alright, so, here. What is going on with the reward debt? It says, we do some fancy math here. Basically, any point in time, the amount of POTUSes entitled to a user, but is pending to be distributed, is actually the user amount, so that would be how much they've staked, or the liquidity pool tokens that they've staked in there, times the pool times account POTUS per share. Alright, so we can see that we're going to find later on here, and oh look, there's something about pool info. So we got an indication here that what's going to happen is we're going to find down here that there's going to be usage of a pool instance of very likely this pool info. See, info of each pool right there. So it's going to be looking inside this thing and seeing what this AC POTUS per share, or in this case, accumulated POTUS per share times 1 to the 12th. See below. And that's what that E means. If you're not familiar with the math, the E is indicating exponent. So it's kind of like squaring. You ever see the number up at the top? Well, we don't have an easy way to type the number at the top, so we just put an E and put the number. So 1 to the 12th, see below. So that's essentially saying that we're going to multiply that by 12, essentially. Because 1 raised to the power of 12 is still 12. Anyway, so in this case, we are going to be keeping track of that pool share, and then we are going to be subtracting the user reward debt. So again, user amount times the accumulated POTUS per share minus user debt. Alright, so the user debt, something we'll also be getting into, reward debt. And so in this case, whenever a pool's deposits or withdraws, whenever a user deposits or withdraws LP tokens to a pool, the pool's accumulated POTUS per share and last reward block gets updated. User receives the pending reward sent to his or her address. So you're just going to get those back. You say on stake, sends them right back to you. At least that's what they're saying. We're going to see that if that's what happens in the code. User's amount gets updated. User's reward debt gets updated. Alright. Well, we will see in the code what they mean by gets updated. What is the actual math? That's coming up. Now, in here, we've got another struct, the pool info. Pretty straightforward. It's describing pools, so it's going to be probably describing each of these staking pools around here, which are going to be accepting the various liquidity pool tokens. Alright? So, in this case, we can see that it's got an LP token. That's what essentially is happening here. So this is just a bunch of variables. It's not intelligent. It doesn't do any work. Not like, some of what the rest of the contract here. It's kind of like the user, where the user didn't have any intelligence in here. It doesn't have any logic. That's the code that we're going to get into. It just has these values, these variables. So in this case, it's got LP token. So this is where it's going to keep track of what liquidity pool token this stake is supposed to be accepting. At least I'm surmising. Pardon as I read through this. I might be getting some things wrong at the spur of the moment that I say them, but if I notice that, when I notice that, I will correct that right away. But my indication here is that this is going to be identifying which liquidity pool this particular instance of the pool, because we'll have several of these in the contract when it's running. There's several of these pool infos that are there, and so this is how it's going to identify which one it is, basically. It's going to see allocation points, so how many allocation points assigned to this pool. POTUSes to distribute per block. So, sounds like that part of the calculation we're going to find here is that this thing is going to be working out what the allocation points are. Sounds almost like a voting system. We'll see how they come up with that number in a moment here. But, how many allocation points assigned to the pool, and then use that in some operation to figure out how many POTUSes to distribute. Alright, kind of like that. How many POTUSes? I'm now tickled by the idea of a country so big and powerful and awesome, so far-reaching in its extent, that it requires multiple POTUSes to operate. We need a POTUS of North America, and a POTUS of Asia, and a POTUS of Europe. We'll have a POTUS of the Moon, a POTUS of Mars. It will just POTUSes as far as the eye can see. Now, pardon, it just seemed funny to me. Alright, so we've got our last reward block. So apparently these things are going to be keeping track of the last block that was mined that issued a reward. We'll see exactly how that works. And then we talked about the accumulated POTUSes per share just a little while ago. Alright, so in here, it's got the POTUS token. Oh my goodness. It's keeping the POTUS token. This is a public variable where it will hold a POTUS token. It will make that available. So this will be something that if you were to engage with a contract your own, like if you brought up My Ether wallet, My Ether wallet has a nice little interface to be able to integrate directly with contract, like call them manually if you wanted to. Or you can actually see, I'll show that in later on here when we're done, that within Etherscan itself, it gives you an interface to be able to call the wallet or call the contract. Now you still need your wallet attached, and you're still going to need to provide funds. It's not some magic system, but if you do want to see what's actually happening, or you someone need to manually call a contract, like if this website goes away for whatever reason, I don't know, maybe it's hosted on Amazon, and Amazon decides this is racist or something, and just shuts them down, I don't know. But, not likely, I haven't seen that happen on a legitimate project. But, in these cases, this is where, if this goes down, so long as the contract is still out there, you can still engage with it. You could technically still interact with it without the website. So technically, you don't need any of this stuff. This is just frills, bells, and whistles. This is something to make it look pretty and to make your lives easier. But, getting into the more detail here. So, this is where it's going to be holding some sort of POTUS token here to keep track of things. This is where it's got a dev address. Well, that's pretty typical to identify the address that, is the dev. Normal to have these because typically with ownership, you're going to have to keep track of the dev maintaining ownership and control of
the contract, at least through the process of getting it going. There are various ways that this access can be removed and it can be locked. That is what is generally termed, you might have heard that on other projects, where the keys are burned. That's essentially it, where quite literally the developer at some point of an operation or some point of the project did an operation where they changed the ownership and said, I don't own this thing anymore. Some non-existent entity, technically the system owns this, and the system doesn't have the ability to do these sort of operations, or at least it's easy enough to stop it. So again, point that it has the dev address, perfectly normal in there. It's got the bonus end block that's stored as a number. So in this case, the end block, since blocks are numbered on the blockchain, essentially this is going to be keeping track of a block where some bonus is going to be ending or doled out. I believe this is going to be the bonus POTUS period ends. So if we take a look at the tokenomics, we can see here that, there is some tokenomics here where they establish that some things are getting double and some are getting extras. If I search the page real quick for bonus, alright, I don't find bonus directly. So, we'll have to dig around, see exactly which one they're referring to. It might see, here we are. It might very well be that during some of the sale, and very likely during the initial launch, that's how they're kind of getting these modifiers here. So it might very well be that ×2. But we will see in a moment exactly what that works out to. I'm just kind of hypothesizing. Let's get to the real facts. And then it's got this information about bonus multiplier. It's marked a constant, so this thing is not supposed to be able to change. And it's got that bonus multiplier of 1. So it's starting off with 1. So a no modifier is no increase of that point. Anything that's worked out is just going to be that bonus multiplier. Now, from there, this contract is storing some information. So it is holding information about what it's working on. That's what this pool info, and the square braces means an array. So this is actually a variable that's going to hold multiple instances or multiple copies of different pool info data structures, those objects. So this is where it's going to keep track of those different pools. It has a field marked mapping. This is where you can kind of like use one type of variable to get another type of variable. Specifically in this case, mapping is referring to the fact that if I have whatever this number is, this uint256, in this case, it would be a number of uint256, looks like the user info, that in turn, if I ask it for that value, whatever that is, then I should get back another pairing where if I ask this mapping for its address, it should give me back this user info. I hate the zoom and how it keeps jumping around when I double click on things. I apologize. So, as I was saying, what it's saying here in mapping is that this one, when I give it some number, so in this case it's getting the info of each user's LP token, so in this case it's very likely passing in the user's wallet address. From there, it is using that to get the address to find the user info. We'll see exactly how that's being used in just a moment. Alright, now, from there, total allocation points 0. So, must be the sum of all allocation points in all pools. Alright, makes sense. It's starting off as 0 because, well, the project's just starting. There are no allocation points, obviously. And the start point, start block. So, this is going to be a check that we'll find somewhere in the code that is going to confirm when this thing should start running. This is a nice feature to find in a contract, especially when there's an expected start, because at the time the developer deploys this, then it is essentially, even if it's out there, even if someone tries to interact with it, anything, if they've used this start block designation properly in the code to confirm things and are actually applying that, then in this case, this thing won't run. If it discovers that you're trying to engage with this thing before that start block has come to pass, before it's actually been mined by one of the miners over time, then this contract just won't work in certain ways. We'll have to see exactly how that's included, but it's usually how that's there. I like seeing that as a safety measure, especially on projects that might have a long pre-sale or a long announcement, where they say, okay, we'll be starting on this time. Well, they can't really give a time, they'll give a block, and then they'll try to give an estimate on how far out that is. So, block in a day. So this is where it is going to be keeping track of how many blocks there are in a day. It's assuming that it's going to take 15 seconds for a block to process. So that's literally about 15 seconds for a miner to get the work, process it, complete it, submit it, get it validated, and make it available. Just a rough estimate. So this might not be perfect. This thing might not be doing its work every 24 hours, but pretty close. This is a reasonable estimate. It's a fine number to work with. I just want to assert here that the way this is working, we're not guaranteed that whatever timer this thing is running on will actually be 24 hours. It'll be pretty damn close to 24 hours, but technically it might be a little off before, you know, how long until it actually, or how much the network is congested, how much hashing there is available to complete the network, and everything else. Now, alright, I know you're getting the question, can they rug? Okay. I'm sorry, I really like the code, pardon. Let me get into what's going on here. Alright, so, from here, we've got some events that can be worked with: deposit, withdraw, emergency. So this is just defining things that the code will want to make the contract and the system aware of. Useful that we've got that. There's an emergency withdraw. Useful that they have an escape valve, if that's named, you know, appropriately for what it's intended to be used. Useful they have an escape valve, but does technically mean that there could be a rug. I don't want to say that yet, right? Just want to point out that having an emergency withdraw is, well, like it's often pointed out in IT and most of the world, you can't solve all the problems. You just have to figure out which ones you're willing to live with. Hence, one of the problems with a pre-locked project is that if something goes wrong when it goes live, it's entirely possible you might get fucked. Kind of like what happened with YAM. So, again, if you're worried about the dev maintaining control, if you're worried about them being able to do something like have an emergency withdraw, understand that's a trade-off, because if they didn't have that access, if they burned all the keys going in, and no one could change anything, then there's a chance that there's a bug, and there's a chance that instead of getting scammed, you could just get fucked and burned by a bad code. But that's part of why I'm here, to see if it's good. So, moving on. We got constructor. Constructor is basically going to get called once when this is deployed, so this has already been done. And in this case, it is going to be setting some values. In this case, it's just going through and kind of making some things match up, and it's setting up what the per POTUS per block is going to be. Essentially just passing some of these through from some of the variables to make them available and used. Alright, now, this is where we start getting into what it does. We've got add. This is to add a new LP to the pool. Can only be called by the owner. Do not add the same LP token more than once. Rewards will be messed up if you do. Useful that they called that out, so good that they are aware of potential problems in their code and have made a note of that. So let's look into see what is actually happening here. Now, for one, it says that it can only be called by the owner. We can verify that with actually how it's defined. How that's defined is when you look at the function here, this whole thing here is what's called the method or the function signature or definition. Depends on, again, language, who you ask. I lose track of what all the various proper names are for each language. I don't care. I've got too many to keep track of. But in this case, technically, the owner would be able to call add. How that would work is, like with a transaction and anything else you're doing, they would have some method to send a request to call add. They would need to pass in the values. In fact, if you go over to, whoops, if you take a look at the contract itself, pardon, I was loading that, I will come back to that when it finishes loading properly, pardon. But when you call the contract itself, this is where you're passing in some variables to tell it what to do. So you're going to be passing in some allocation points. You're going to be passing in a LP token. So you're actually going to have to provide that token. Because I want to be clear, we're not providing an address. We have to provide a instance of the token. So that's also a good safeguard to find in here. So the developer has set it such that when they add an LP to the project, they have to have already bought into that LP, that liquidity pool, in order for this to work. Because they're not sending in just the address for the LP token. That's nice. Also means that they'll have access to the LP token and can actually work with it a little bit if they need to. And from there, we will have a bool with update. Now, at the end, because this is called public, that means that it can be called from outside the contract. Earlier, we had an internal one. This can be called from outside. Reasonable. Its whole point is to set this thing up. And it's marked only owner. This is a designation. Technically, there's some code behind it, but it's a standard one in Solidity and pretty much all of Ethereum, which is providing what's called an access modifier, a definition where it's stating that only the owner, the person, the wallet that has the same address as was marked as the owner in this project is going to be able to call this. If anyone else tries, there's a check that's done before this thing is ever called that actually does that check. All right, now, here we've got information where it is going to check to see with update. So it's first doing a check to say, okay, should I actually update? Yes, I am told that I should update. All right, what does that mean? Well, that means that we should go call mass update pools. All right, so apparently when we add a token, we have an option to either update a whole bunch of pools or just add one in. So we'll remember that right now. We'll go take a look at mass update. Actually, to be honest, we should go take a look at mass update pools now, especially since we can see that it's just right down here. See, mass update pools. The fact that it has these these parentheses means that it's actually defining another method, another function in here to call. So down here on mass update pools, right there, we can see that this is another public method. All right, so public. And looks like it's going to be very costly to go through this operation. Yeah, there's a lot of work getting done in here. A lot of stuff is getting accomplished in this call, so this would be a costly operation to do. And in this case, you're just calling it. It is taking a look at how many pools there are. It is then going through that list of pools, or I should say, yeah, going through from there and actually checking to, yeah. So it is going through them. It is going to update the pool. What it is going to work off of is by getting setting a pool ID to 0. So it's literally just going to be looping through all of the pools. It's keeping track of looping through all of the pools because in computers, we're weird and we actually start counting at 0. So it's going to start at the beginning. That's the 0. And then it's just going to keep going through this update pool. So it's just going to keep looping through this. That's what the for means. And it's going to keep passing in that PID, or I should say, going to keep iterating over that PID. So it's going to iterate over each pool, or call each update pool for each instance you pull in there. It's going to keep doing that for however long that pool is, so however many pools are in there. So it's a good solid code. It's going to iterate through, update them. It's doing this update pool by passing in really just an index. It just essentially they're just saying I want to talk to pool 1. I want to look at pool 1. Then it'll get incremented to from 0 to 1, and that'll mean saying I want to look at pool 2, and then it'll do this check to say, okay, if I reach the end of the list of pools, yes or no. If I haven't, then again we'll increment that again. That's what this line at the end means, and keep going. So we need to look at what update pool it does, and lo and behold, here is update pool to make our lives easier. So in this case, it's telling us that it's going to update reward variables for all pools. Down here for update pools, it's going to say that it will update reward variables for the given pool to be up to date. Function mint, public only owner, POTUS mint, and that dev address and an amount. Alright, so it does look, and we're going to probably see this in here, where it is going to mint tokens. And yep, that is what it's doing. Alright, so this is where we will want to go back and look at the POTUS token info itself to be sure exactly what's happening. But what it's doing here, when it's saying mass update pools, for the investment scheme, the profit scheme where they're getting you that information, or I should say getting you that profit, those fat gains, hoping to shoot this thing to the moon. Or at least have some fun with a actually somewhat reasonable tokenomics on a meme coin. I love the merger of memes and actual finance. I can't wait for the day that I can sit in a big business meeting with like Prudential and tell them they need to be making use of Sushi Swap and POTUS coin. It's gonna be so much fun. Now, here when it's going through that update pool, it is again being iterated through by this mass update pool. in here, it is going to go through the array of pools that it has, that pool info. Remember that number, that PID is the index in the array, so it's just going to go through them one by one. So it's going to pull out that one. It's going to hold on to that. So that's that storage saying, all right, I want to get that, and I want to be able to refer to this pool later. So again, the pool that we see here is whatever instance of the pool definition is at that index. Think of this as a big list of different pools in a particular order, and the order stays the same, so you can reliably go through that in whatever order you want by just pulling out a particular ID. Now, it's going to go through, it's going to pull out a particular pool, it's going to check to see if the pool's last reward block is greater than or equal to the current block number. Now, we don't have a block variable anywhere in the code. That's because the block variable is just part of the Ethereum VM. It is an object available to the contract while it is being processed by a miner to tell it about what it's doing, like what block it's in. Things like what user has sent the transaction, stuff like that. So in this case, it's just basically going to get from the system, all right, what block are we on? And it's going to check to see, okay, if the block number is less than or equal to, so if the block that we're on is less than or equal to the last block the pool was rewarded on, then just go ahead and end. That's what the return means. Just forget the rest of this stuff. We don't need to do it. Just be done. That's basically saying that, okay, for this block on the blockchain, this set of transactions, this is doing the check to say, well, wait, I already did that. And so this is a protection so that at least you can't update the pools, which means you won't be able to mint tokens more than once a block. That's handy. Simple enough. And that's per liquidity or pool. So it's not even a matter of the pool. It's not even a matter of calling one of the different methods. It's an initial check to say, all right, this block, we already updated it. So while we have a minting function, which is normal and appropriate for a profit scheme like this, where the POTUS coins are being created as part of the reward, as part of this kind of on-running game and giving it away to have as much room to run as possible, it is doing a reasonable check to make sure that that can't inadvertently get out of control. It just means that it'll be rewarding at least once every block, preferably more often. Anyway, now, in here, it's going to be going into the pool. It's going to be accessing the liquidity pool token. It's going to be asking the balance of, and it's going to be passing in this, or the address of this. So in this case, it's going to pass in address, or it's going to call that address method that we saw up above, and it's going to call or pass in this contract or this particular address. So literally, it's saying, okay, go check the liquidity pool balance of me. Because in looking at this pool and the token and the balance of, it's essentially establishing, all right, this is essentially my pool token because you gave it over to the contract. You have a way to get it back. I mean, that's the whole point of staking and getting the coins back, or getting staking coins back. But technically, it has your liquidity pool token. And this is it saying, well, I got that. I want to go look at it. So we got two things we need to look at. We want to double check the pool info that we saw. We did that, but might be useful to double check that if you're not familiar with this. And we do want to go double check the usage of this LP token balance of that's coming off of the pool, the pool and then the LP token. Now to be clear, when it's saying that pool LP token, remember right here, we've got this and this IERC20 that we have our definition of. So if you'd like to see what happens when we actually call balance up, and I know this might seem exhausting, you're like, God damn it, man, why are you reading all of this? This is what it takes, man. Like, this is really what it takes. And I'm going fast because, there's not like an insurance bond or anything on the line. I'm having fun goobing with people. But I just want to highlight here, like, you do actually need to check this because right here, down there, when we're asking the liquidity pool token, hey, how much do I have of you? What is my balance of you from the contract so it can see how much do I actually have available so it can do its calculation. It's literally going up here and calling this. So if you just take for granted, like, it's a token, it's a standard interface, standard function, all of them have it, it's balance of, it all does the same. And then you don't come look up here, well, you're not entirely sure that they didn't slip something in here. Now, most of this is injected by the compiler and is handled automatically with simple statements, but technically, there are ways to slip in some modifications here and there. to make this kind of work like it's supposed to, but then slip in extra things. So you really do want to come up here and go check every single line of the code. Make sure that there isn't some silly little thing slipped in there. So far I've got nothing. I've seen well-structured code, so I'm now just making sure I do my due diligence and show everything, and make sure I tell you guys that if you're doing this on your own, because I can't do every single one, but enjoying this, but you know, I do have to sleep, and I got a goddamn day job I enjoy doing. But you guys can do it on your own. Make sure you actually follow this around. You can see there's a reason why I went through the order that I did. I found an entry point where I found a public method, started following that through the system, and then found, well, how it's actually operating. So, in this case, as I said, we go through mass update, we go through, where were we? Pardon. Ah, yes, there we are. So, we were coming through there, we had our various operations, and then, yes, we had our update pool. That's where we were. Thank you. So, here in update pool, as I said, it's going through, it's going to be checking its balance, it's going to be seeing then, alright, do I have at least some? Alright, if I don't have any, there are no more liquidity pool tokens in there, then go ahead and mark that the pool's last reward block is this reward block. Essentially saying, okay, if I don't have any of the tokens appropriate for these pools, then go ahead and mark that as whatever we are now is the last reward block. The way this is written, this indicates to me that this is that initial check when this thing starts off, because this thing won't necessarily know what block it's starting on, and it kind of needs to be able to figure that out. So this is essentially just there to do that basic initial check to say, okay, when you call me, actually find out whether or not I've ever done this before. If this is my first time, then just go ahead and set it up so that I can do it next time. And then we can get going. This also means that this thing is just going to kind of idle, not really doing much until liquidity is actually deposited. But as we saw and hypothesized earlier from that, liquidity is going to have to be deposited at the time that it's there. But this does also give the dev a nice trigger on this thing. Is that since the owner is the only one that can update a pool, or add that in, and the update and the add is how you update them, and this is going to be called later on through some of the operations, this does mean that when this thing gets deployed, technically until the dev deposits the liquidity pool tokens to kick this whole thing off, even having the contract out there means it can't do anything. So, it first has a start block that it could be checking for to see whether or not it should even be running. Second, it has a check to confirm, have you actually turned on the pool by adding it and adding in the token? So, again, in this case, that's providing us a good description. Oh my goodness, I am getting a message from our president. I'm sorry, hold on, I should stand for this. Alright, sir, what do you have to say? Oh, god damn it, Discord, why you have to be such a bitch and not load? Oh, perfect. I am getting the messages from our president. He is telling us that he wanted to ensure that he'll be handing the keys over to a multi-sig wallet for known community members, trusted, but they haven't decided who yet. So, looks like we are going to be getting an informal DAO in the form of having a wallet where these keys will be placed when the whole thing kicks off. So that's good. As I'm pointing out, this thing has a lot of checks in it to make sure that it doesn't kick off inadvertently by just being out there. So that is perfect. That means that as this thing is running, it's waiting to be initiated, and thus the dev can execute a nice operation where they can structure the operation such that they will issue the transaction, it will deposit the necessary liquidity to get this thing going, it will go through, get everything set up, configure it for its first run, and if they structure it right, will automatically dispense the tokens or exchange the ownership over to that multi-signed wallet, and then once that's in there, we'll be able to track that through how to track the transactions, because after I finish the code here, I'll be getting into how to audit the transactions for a contract to confirm that no shenanigans have been pulled before this thing even got out there. Because that's why it's important to look at the constructor. Looking at the constructor, it's called once when this thing is deployed, might not seem like a big deal, but if they do something weird in there, if they mint a bunch of tokens and secretly give them to themselves and don't tell anyone about it, be a perfect place to do it. And so, we can confirm that none of that's happening here. This thing is just sitting here, idling, waiting to have somebody kick this off. And that'll be the owner, and then once it's done, the keys will be put into a multi-sig wallet. It'll be a group of the dev and some community members that they will decide on in some manner. We'll be able to decide if that change ever needs to be made. Now, I'm gonna give some recommendation on I'm sure you're aware, but I'm just saying for people at large, be cautious on who those community members are. Make sure that they don't disappear, that you don't lose contact with them, that you have some sort of safeguard. I have seen, for example, where you have multi-sig wallets where a certain number of the total set of keys has to be used. Examples for cases where, say, you might have a 4-signature multi-sig wallet, and one of those signatures could be deposited in a time lock vault as a safety measure, and you can configure the vault to say, okay, you're going to need any three of the 4 signatures to sign. We're going to pass 2 out to community members. The dev will hold 1. 1 will go in this time-locked vault, and thus, worst comes to worst, if there's we call it the bus factor in coding. If somebody gets hit by a bus, and we lose everything they're involved with, how does that affect the project? And so, one of those community members, as morbid as it sounds, we are dealing with high finance here. Alright, we may be DeFi degens, I may be the DeFi degen doge, but we're dealing with high finance here. This is the sort of shit businesses talk about. Because as morbid, as sick as it may sound, as like macabre it might be to see some like tiny little squirrely guy in a suit asking, so what happens if you die? It's a legitimate goddamn question. Because sometimes if a project lead dies, if a CEO dies, the whole company's literally fucked. So, bus factor, important thing to consider, maybe some consideration there. But I'm just going on about some options. Since we just got a message from our president, I am so honored. I'm sure he's about to tell me more on that consideration. I don't mean to bring it up as like warnings or telling people what to do. I'm laying out for you guys, the community that are interested in investing in this, as to whether or not this is viable, whether or not this is useful, and so that you know your risks. Because it's not a matter of, you can't have no risk, you can't solve all of it, but you can just decide what you're going to live with. So, again, we've got that update pool. It's going to be going through, waiting for that first deposit to be able to kick off. It's then going to check in that block. All right, so to be sure, have we gone past the block where we were last rewarded? It's just doing this basic check here to say, all right, have we already awarded for this block or not? It is then doing that confirmation of the amount to reward, and in this case, it's figuring out the POTUS amount to reward by it's taking the block past. So, what it's doing is it's looking to see what block on the chain are we doing this on? Which one? Alright, I want to get its number. So, which block is this? I want to subtract from that. So, to be clear, we are subtracting from this current block number the last rewarded block number. Oh my god. Why do you keep doing this to me whenever I double click? I hate you, Etherscan. Alright, so it's going to be doing this and saying, alright, subtract from the block number where we are processing this reward from, oh, I apologize, not from the president community members, by the way, owners of proven other coins. Excellent. Also other project leads. Excellent consideration. Still bus factor, though, I will say. Thank you for clarifying, President. I apologize for getting that wrong and making assumptions, and thank you for having the grace to correct me so politely. It is an honor, sir. But in this case, I will just point out for the audience that it is useful to be passing it out to professionals that are aware and already have a stake in the industry and have probably already profited, and so I don't have much incentive to steal things. But technically, we still have our bus factor. So again, just want to be considerate there. Be cautious. Be careful. I don't want to see something like this burn because some idiot wandered into a riot. I'm sorry, protest. So, with the peaceful protest going on and keeping us indoors, we have now, going through this, like I said, it's going to look at the block we were processing this on. It's going to subtract from that block the last one where we rewarded. And that is the one where it's going to say, so I'm going to say, all right, how far out are we from that block? How many blocks between there? From that, it is going to take that difference. So when it says block passed, when we're subtracting, we're figuring out what that difference is. It's going to take that difference. So for example, if it's now 2 blocks after when the last reward happens, so that's 2, well, difference of 2, then that's going to end up being 2. If it's saying like on block 1000, we did an award, and then at block 1002, we're way past 1002, but at block 1002, we're doing the calculation to issue a reward and update the pool. Well, at that point, we have a difference of 2. So that is where it is going to be coming down and multiplying that by POTUS per block. So at this point in our hypothetical scenario, we've got 2. We're going to multiply that 2 by POTUS per block. Where the hell do we get POTUS per block? How does that one working? Well, we know that this is not something we're passing in. POTUS per block is back up here as one of those properties. Aha, here we are. There we go, POTUS per block. It's not set here. Aha, it is set in the constructor right there. And so it is set at 5553 finey. All right, so we're going to be getting about 5,353 from there. Finny. We get so many weird words in coding. It's fun, but also annoying sometimes. Anyway, so that's going to start off by multiplying it by 5353. Cool. So we're going to take the block that is passed, in this case 2. We're going to multiply it by 5,353. So that's going to double. We're then going to multiply that by the allocation points. So pool.allocation points. So recall here, up under the definition for a pool, there it was, for the pool info, where the pools are, that's going to contain the allocation points, so how many are assigned to this pool, and so POTUS is to distribute per block, so we'll get into exactly how it's going to calculate that in a second here. Right now, we're just going through the process of how are the rewards dispersed, and I know, it may seem like I'm taking a while, but quite literally, we got to go through this line by line. I mean, you probably heard about some of the errors, like some of the projects out there. Oh, geez. Yams just had their rebasing token just completely shit the bed. Hot Dog was just a stupid fucking design. Those guys don't understand economics or how money works. I'd be surprised if they could identify a dollar bill from a British pound, for fuck's sake. But, inherently inflationary currency? Why? Anyway. In this case, we are working that calculation for the allocation points. I know it's annoying to go through it all, but we do have to do it. We gotta make sure there's not some weird little bug that somebody didn't, like, reverse a symbol and subtract something when they should add something, or multiply something when they should divide something, or whatever. It's annoying. But going through this is why people get paid lots of money to do this. Speaking of which, there's a like button. There's a subscribe. You could totally let people know about this. I also work for tips. There's links in the description and the channel for being able to donate. I will take super chats with questions, and I will take donations at my experimentation wallet, coyote.eth. So, I have no affiliation with the team, not getting compensated by them anyway. I am doing this for the love and the desire to keep this space pure. Because the last thing I goddamn want is the fucking feds coming in here saying we need regulation because we got too many goddamn scammers. I want scams not to pay off because I want you guys to know what you're investing in. Really. I do. Because I really don't want to deal with the other problems if you don't. So, in this case, we're going to multiply it by the pool allocation point, where I'm going to have to get into how that allocation point is calculated. We're going to divide that by the total allocation points. Okay, so there's going to be a total. We're going to figure out what portion, effectively, this is. So, might it seem like it's getting crazy, we're multiplying and multiplying, but then we're going to divide that by how many are out there. So we're kind of figuring out that disbursement of each. What's going to happen there is that POTUS, the token, is now going to mint more. What it is going to mint, that means it's going to create more tokens. And okay, this means, once again, we got to go back up here, and we got to find the mint operation. Now I want to highlight here, when we're looking at it, notice that little underscore right there in front of mint? This is not the method it's calling. This is normal. It is normal to have a public method that is in front of or wrapping around a private internal method. But I want to highlight here that technically that's not the one that's being called. So if we really do want to follow the operation of the code through here, we got to find where that mint is. Now I know I could be doing Control F. I'm sure people are mentioning in the chat. I apologize. Here we are. POTUS token, right here. What is POTUS token? Well, it's defining itself as POTUS POTUS. That's its name is POTUS. Its symbol is POTUS. It is an ownable contract, because tokens are technically just contracts, and it has this mint operation. It is the mint. It is taking a argument of what address to send the coins to, and it is taking an argument of how many to send to that particular address. And what it is doing internally. First, it's saying that only the owner can call this. Fantastic. There are ways to automate this by having another contract that becomes the owner of this contract that is managing these things, and then you burn or lock the key to that contract. So I want to highlight here that depending on how this thing is designed overall and how it's being managed, it's entirely possible that technically the ownership for this contract may never actually be burned because it's not appropriate. That is not what you should be doing with it. It might get transferred to another contract that manages this, and then the key to that contract would likely be burned or locked away in the multi-sig wallet, as they said. In other cases, that's the one that might be burned. But this is how you can have a case like this where we need to be able to call this method all the time. Like, this thing is getting called, this could get called every block. We can't expect our boy the president here to be sitting there calling the mint for us every single time. I mean, Trump's not even doing that. He's got the Fed to handle getting the mint to mint more money for him. And to be honest, the president's got better shit to do. He's got to fight China. He's got to deal with, like, the horrible, not necessary lockdown. He's got to deal with India. Like, India's being big boy and starting shit with China, but that might be getting a little, like, I like India, but could you not start World War III, please? I got gains to stack. So, in this case, this is where likely this is going to be managed by a management contract above that. So, from here, it calls mint. Notice, that's where the underscore is. So it's going up to this other method, and is doing all of that to protect it. Because notice here, the standard mint operation for these things, it is an internal method, but it doesn't have any check on who can call it. Now, some places would override this and stick that check in there, but a lot of contracts on a well-designed contract will do what our boy here did, our beautiful Trump boy, who's done the work, made us this sweet, sweet coin to stack those gains and fill our bags and have some fun too. I mean, I kind of love that we got the whole thing. I don't know what's wrong with McAfee. I'll get to him later. But in here, to be clear, this is where he's doing it in a nice, clean way. He is checking that with this only owner before we ever get to the original mint method. Now, what is happening here is this is receiving that address to send to. It is receiving an amount to create. In this case, it's required. This is doing a check in the code to say, if this does not work out to be true, if what I put in here inside this require, basically this little logic right here, the address does not equal address 0, then if that doesn't work out to be true, then instead I want you to send out this message. I'm sorry, if it does work out to be true. If this does not work out to be true, if this does not work out to be true, then I want you to send out this message. If this is true, then you can go ahead and continue on with this operation. So, in here it's saying, in order for this to work, we have to make sure that the address that we're sending the tokens to is not address 0 on the blockchain, which is the system, basically. It's whenever you see address 0, that one's safe. Address 0 is the protocol. It is the chain. Kind of effectively, it's the miner, technically, at the time this is running. Like, every time a miner mines a block, it's kind of technically address 0 for the time that it's mining the block from the perspective of the contract. So that's also why a good contract will have all these various checks in here to say, all right, address 0 doesn't get to do things. Because even though, and this is called writing defensive code, and it's good that you have these extra checks in here. These defensive code is useful. Because what that is meaning is that it is trying to safeguard against a miner possibly being malicious. Now, that's highly unlikely. they'd have to break the encryption. They'd have to like figure out some way around the protocol. And to be honest, we've got nation states trying to figure that out. We've got massive multinational global corporations. The reptilians are trying to figure it out. The Greys, the Men in Black, MI5, MI6, the CIA. Again, no, the other CIA, not the first one. Vatican 1 and 2, the Illuminati, actually the Bavarian Illuminati, and then just the other Illuminati. They're all trying to figure out how to break this shit open. I think the only ones that have figured out is the Gnomes of Zurich and the guys living in the center of the moon. The Nazis on the dark side of the moon have not figured out how to crack the encryption used here, so we don't have to worry about that. But here, unless this is safeguarding against some future problem where maybe a miner could figure out to fuck with things, and in figuring out how to fuck with things, it does manage to actually get into and try to like change the address or something, or say, hey, give me something, or let me replace the address that you're trying to pass in here. Doesn't really happen terribly much, but we will see. Okay, now, in this case, when we are going through, it is going to be looking for, or calling before token transfer. Oh god. Alright, so, more that it's doing. We gotta find this before token transfer. And now I'm getting tired of scrolling around, so yeah, I'm gonna cut and paste, or copy and paste, and I'm gonna search for it, even though it doesn't work so well on the Zoom. Alright, so, before token transfer, we've got one call there, we've got... Aha, here we are. We've got our function before token transfer. Here, we've got our comment saying calling condition. When from and to are both non-zero, amount of from, so... Alright, so they're just basically laying out for us what a transfer is. And it's laying out the exact logic. In this case, it is a hook for something that can be handled. It is making this point of a virtual check, or a virtual internal operation. That means it's not actually real code, it's kind of a reuse of something before. And so in this case, it's just kind of checking this point of that before token transfer of exactly where some of those things are going and exactly what they are doing. Now let me see here. Where do we... Alright, yep, so that is literally the end. Okay, just wanted to be sure there wasn't another entry there. And so again, this is a hook. It is something that is included or it's working in the mining or the minting and burning. And in this case, we can find information about the contract hooks, but the point here being is that this is an operation that's kind of out there that can be called, and thus reuse existing code, reuse some built-in functionality, and thus mean that we don't have to necessarily... we can inject logic here if we need to through this virtual method, or remove that. So again, it's a hook. We can take a look at what the extending contracts here is and what those using of the hooks are. In this case, and I'm showing you this here because you'd want to look this up, because if you don't understand what this is referring to, then you're going to want to figure out what the heck... Sorry, because I zoomed in to make this more readable. It wants to act weird. So this is where you'd want to go look to see if you don't understand what that means. In this case, we know it's solidity that we're working with. We can literally go search for these terms. And we can go see here, like, what is this going on with the various points? And oh look, how to use before token transfer. Now technically this is coming through OpenZeppelin, but as we can see, we have a general question here on OpenZeppelin asking about how to use this. Again, this is just something I'm finding here to try to figure out, like, what I would explain it to you, but I want to explain to you or show you guys how when you come across something like this, you can figure out what's happening. Now, in this case, we don't care what they're asking about. Because this is a fairly standard operation, we want to make sure we are using this appropriately. So, in this case, this person's trying to use it. They're asking a question. We have an answer down here. And so here, see, it says that a hook allows you a lot of flexibility in modifying the behavior of a token by allowing you to execute functionality. In this case, the hook, you can execute functionality before the token is transferred. You could restrict transfer. You can mint another token. You could signify. And so essentially the whole point here is that in what the token is doing, its intention is, as being that hook, that override, is to say, okay, in these cases, when you're going to go do something with that token, I'm kind of surmising here from what it says, if you would like to be absolutely sure, you can do things like find the various documentation, like right here where there's information, or getting started with blockchain development. See right there? It gives you a description and describes it. But I will not waste more time on that. To be clear, though, that's what I'm talking about here, is that this is a way to basically have an operation that will occur before something else. So this is kind of establishing, okay, before we transfer tokens, I want you to call this and find something out. To be honest, I will have to ask the dev why this is empty. A little weird to have an empty hook there. Now, mind you, this is on the chain, and so it kind of doesn't matter that it's empty. I mean, it's not like they could stick something in here. It's just a little odd that we'd have an empty hook there that doesn't seem to be doing anything. Maybe it's leftover from including the library. It's actually pretty common to find that when you bring in reused code like this, that there will be some leftover code there that you don't care about that was useful for something else and you just don't touch it. So, all right, now, in this case, we have what is happening is doing this before token transfer, so technically nothing is happening here. It's just a step that is implemented in this method. And again, this is coming from the main library. As we saw, it is defined here as this ERC20 contract. This is not something the dev invented. This is something from Ethereum itself. This is just how it works and how it operates in OpenZeppelin. And so down in here, and OpenZeppelin being the method that it's, or the framework that it's working with, OpenZeppelin has this option for a hook and a thing to be done. It's probably that OpenZeppelin has this definition of how the contract is implemented and it just stuck that in there all the time and doesn't really care. Now, in this case, the burn, what this is doing is it is going to go to the collection of balances that this token is maintaining, because it keeps track of the balances for the various accounts, and it is going to pull out whatever account is sent in, and in pulling that out, because quite literally that's what's happening, saying, look, go to the balances, get me the balance of a particular account. With that balance, I would like you to subtract an amount from that balance, and the amount that it's going to take out is the amount that should be burned. And it's going to then make sure that's set. So essentially this is saying, I just want to update this account to remove some tokens. Okay? It is going to be looking at the total supply, and not only is it going to reduce one of the accounts that it's keeping track of by that amount of tokens, but it is also going to reduce the total supply by that number of tokens. So those tokens are now gone. They are missing. They will not be around anymore. They do not exist, and there cannot be more. All right? Now, in this case, we then see that it is going to emit that transfer. That emit transfer, that is the contract telling the system, hey, I just did something. I want you to enter that on the blockchain. So when you look at the transaction hash and you see some statements like, oh, I did this transfer and that transfer, and here's the address, this is quite literally the contract putting out that information so the miner can put that in the transaction hash on the blockchain. All right? So with that, getting back to our main point here. Where were we? Yes, we're update pool. So we can see through this. It's going to go through and mint. It's going to mint to this address. So to be clear, when I was saying before that it's going to burn tokens from an account's address, notice that this contract will have those tokens. So it is only burning the tokens that it has for the purpose of running through the tokenomics, all right? So I don't want anyone to worry. I can verify here that the way we've worked through the logic, the fact that we followed this step by step, we've been able to confirm that, okay, this thing, this contract is only going to be working with its own balances. It's not going to try to do something weird or funny, all right? Mind you, it couldn't really affect your balance anyway, but either way. Now, if we come in here, it's going to be doing that check to see, okay, is my liquidity pool supply 0? All right, if a pool is empty, fuck it, forget it, don't care, moving on. Oh, wait, sorry, we already covered that. We're down here to the mint. All right, so in here, it's then going to figure out, all right, what is the accrued POTUS per share? Aha, so this is where we get that number that we saw in the math up here, or up earlier that we said was going to be included. All right, so what is that? Well, that is being figured out by looking at the pool, figuring out what its accrued POTUS per share is, and adding in the POTUS reward. So remember, it does all of this math here to figure out what that value is. Takes the difference of the blocks between when it was last awarded and now when it's being processed, subtract or multiplies it by the POTUS per block, multiplies that number. That's what's happening here with these calls. These dots are saying, all right, take the result of this operation and pass it in for the next one, and then the next one, and the next one. So it's taking this point of pool allocation points. So it's going to multiply that again, then divide them by the total allocation. And so this is where it's updating that the POTUS, accrued POTUS per share. It's adding that in. So it's taking this reward after it does all this math, it's multiplying it by 1 to the 12, and then dividing that by the entire liquidity pool supply. So basically, this is its operation saying, okay, how many POTUS should I give you? And saying, okay, well, we're going to look at the pool. We're going to figure out, based on the tokenomics for this thing, what your POTUSes per share of the reward should be. And then we're going to add that in by taking how much POTUS we should be awarding based on the total allocation, the pool allocation, and which block we're on. And we're going to divide that by the total supply. So that's just saying, all right, figure out how many of these things to give out to each token, or per token of this supply. Having done that, it updates that accrued POTUS per share to keep track of it. And then off it goes to the next reward block. Marks it and say, all right, I've rewarded for this block. We are moving on. All right, cool. We figured out what update does. We figured out what mass update does. Oh, God. All right, so this is a long contract, guys. So we can then come back up to what we're doing here. So we had our add. We had that going through. We had it possibly do a mass update pool. So when you're adding a whole new liquidity pool, you have the option of passing in a true or false variable. Just, yes, I would like to mass update the pools. No, I would not. To have it go through and update all the pools. So at the time that you add a new liquidity pool, you can also have it go through and rescore all the pools. Okay? We're likely going to find that that update pool call is done elsewhere, that mass update pools. So in this case, it is going to be going through and saying that it wants the last reward block to equal the block number. And so here it's just confirming, okay, so long as the current block number that we're on is greater than the start block for when we set this thing to start. Remember earlier I said that when this thing launches, you can set a start block there. You can pass in a value and say, okay, this should start with this start block. Well, it's doing that check to say, okay, should I even bother doing this? Which means that as this passes in, it is entirely possible to try to update the pools. I want to call that out here technically. Is that if you call this and you pass in a pool and you say, okay, update the pools and distribute the tokens through this process, it is technically possible to just deposit liquidity pool tokens and then update the pool, so make it do its scoring the first time, technically, before this thing is really supposed to start. But that's fine. That would work as intended for this scheme, because the developer would want to be able to throw that in, prime the system basically, get it started and ready to go, and then let it run. I know for you guys asking, is it possible to rug? I appreciate you not spamming, because you can see I'm working on it, man. I don't have an answer for you yet. This is a long contract and it does a lot of stuff, so we got to figure it out step by step, and I appreciate your guys' patience. So going through here, it's going to do that. It's going to check to see, all right, should I even be operating? If this is true, we'll continue. If not, then we'll remove that. Oh, Jesus. I forgot to turn off my ringer. Fuck, that's terrible. How terribly unprofessional of me. Alright, so, in here. Where was I? Alright, so, it's also going to be figuring out the total allocation points. It's going to be adding that by adding in the allocation points. Alright, simple enough. And it's going to be doing that by adding in whatever that allocation point is at the time that we kick it off and we add in the pool. So eventually we're going to prime that again. Just get it started with some number to set it up. And then from here, it is going to send out the pool info. So this pool info.push, that is a definition in the pool itself
we could see up here in the pool info what is happening. Well, we see no push here, so what's going on? Well, push is actually, again, part of the language, part of the code. A lot of things have a push option. And so it is establishing that what it should be setting or sending into this pool info is, it should be adding an instance or definition of the new pool info. So this is really just a way of saying, okay, look, I need a pool info. I need to create one, and I need to add it in here. And how it's doing that is by sending in and saying, all right, I've got new pool info to send in here. Here is that pool. Here is the liquidity pool token that should represent that. Here's the allocation points. Here's the last reward block. Again, it will figure that out. And what the POTUS allocation share, or 0. And again, in figuring that out, it's going to go look those up. So saying it needs the LP token. Well, LP token equals the LP token passed in. Well, this thing needs an allocation point, or an allocation of points. It's going to go look and say, okay, well, the allocation of points is what you've passed in here. It's going to say, well, I need to know what the last reward block is, and say, well, your last reward block is the last reward block, what we last set it to. And then, what is your accrued POTUS per share? Well, we're starting you off, we're just adding you in, so you have none, alright? Pardon me, need a bit of a drink there. Alright, so, going through this, oh my goodness, so much to go through. Now, we've got an operation of set. Again, this is one that can only be called by the owner. Set, its intended is to update the given pool's POTUS allocation point. Can only be called by the owner. Alright, so set, we're passing in that PID. This is, again, we saw earlier in the work that it was a pool ID. There was an iteration through that we saw. So, in this case, we're passing a pool ID. There is an allocation point to set with. We're going to say, do we want to update the pool? So we may or may not be doing that mass update again like we saw. We don't need to go through that again. And it is where it's going to set the total allocation points. So it's going to take the total allocation points that are currently there. It's going to subtract by going to pool info, pulling out the pool that we're trying to set here, that we're trying to work with. It is going to check the allocation points that it currently has. It is then going to, so it's going to take the total allocation points, it's going to subtract from the total allocation points that are out there the number of allocation points that this pool that we're setting or engaging with already has, and then it's going to add the allocation points that are sent in. And so essentially this is just a way to hard change the POTUS's allocation points. So again, it can only be called by the owner. Very likely this is a safety mechanism, so that if things do get out of hand, if something does go awry somehow, then again, a safety valve and like an emergency release hatch that the developer could technically reach in here and just change those numbers. Now, to be clear, that's not a rug pull. Alright, that's not really a problem. It does mean that the game can be jiggered, technically, because this is public and only the owner can call it, but this is perfectly fine in my opinion, provided you're going to trust the dev. They give no indication not to, and the code's written well enough, and the disks didn't give indication they're looking to maintain this and work with it. But, I mean, who knows, we might have this again in 4 years. We also might have a civil war by then, so who knows? We might have like 2 or 3 of these in the next 4 years. God, I hope not. Now, in here, just to be clear, kind of a safety valve. This gives the dev a chance to just kind of step in and just change things. And this is a safety mechanism. Say, look, I know you were one thing, I'm going to change you to another. Boom, here you go. I get to change you to something in case there's a problem. Now, in here, we have another public where it is a get multiplier. Now, in this case, with this returns, it's expected to give information back. And so, since we can see here that it doesn't really seem to be doing anything, again, as you saw before, we had to have this equals. So again, when we call subtract on a variable, we don't change the variable. We have to set that. That's giving us a result, and if we want to change the variable, we have to equal it to that. We have to say, look, set the variable to the result of taking what it currently is and doing this math with it. So I want to highlight that here because
Down here in the get multiplier, this is just returning information. So we kind of don't need to give a shit about this one, to be honest. We can tell right here that all it's doing is doing some checks to say, okay, tell me information about how this is running, and then just do that on some conditional statements. So I can go through it, but essentially just saying like, okay, look, is there a bonus end block that we've reached? If so, return this multiplier. If not, then return this other multiplier. It's figuring that out by taking whatever our 2 is that's passed in here and subtracting from that the from. And so again, it's probably going to be expecting to receive block identifiers or block numbers for each of that to figure that out. All right. Essentially, it's just doing some math to help this thing run. Technically, you could call it from the outside. Now, we have here pending POTUS. All right, view function to see pending POTUS on front end. So this is quite literally where, when you look on the system, it should be showing you what the pending POTUS is in the various operation. All right. So again, pending POTUS, we can see that in this case, it is getting some information out, but I want to point out here that it is not setting these to something that already exists. This is an entirely new definition. So this is essentially the code is just going to the pool info, and saying, okay, look, give me this because I want to look at it. Give me this other thing because I want to look at it. And it's going through the various information, collecting that. It is doing some basic checks to make sure, okay, that has there been a reward? Has there not been a reward yet? And thus doing that to determine and to make sure that, yes, there are still tokens to award. It is going to be doing this math to establish what it should tell you the user's multiplier account is. So again, this is going to be based on the user, you. So this is when you are connected, when you are logged in and connected to this thing and looking at it, it will tell you how many POTUS are pending to come to you at that moment. Now, I want to tell you that from looking at this thing, to be clear, that doesn't necessarily tell you what you will get. That is telling you what it would be if it awarded to you right now. As we saw, that can adjust. Does seem like it goes up, but looks like there are cases where it can go down. We'll figure that out as we go along. Now, we've got our mass update pool. We've got our update pool that we looked at. All right, we've got deposit. Public. Deposit the LP tokens. Okay, this is where the magic happens for you guys. This is when you click that little farm button and you send in some of your LP tokens. What is this thing actually doing? Is it actually transferring it to the developer's wallet? Are they stealing all your money as you deposit and just showing you garbage? No, it doesn't look like that. What they're doing is they are wanting you to, or when you call this, so when you click the button on the website is sending in this information, and it's sending in the amount that you want to send in, and it's sending in the pool ID that you're staking into. From there, it goes and gets that pool from the list of pools, this array. It goes and gets your information, and it does that. This message.sender, that's looking to see what user, what contract called this method. What contract wants to deposit tokens. So it's doing that check to say, all right, I'm going to go get you from the user information. I'm going to update the pool for the pool ID. So we saw the update back there. So it's going to be doing that calculation for just this pool. It's going to be calculating it to say, look, so long as the amount that you're depositing, or the amount that you have is greater than 0, it's going to look at you. So again, your address, your point here, or your entry in that pool, and say, okay, if the user's amount is greater than 0, then I need you to figure out what the pending is. So I need you to look at their amount. I need you to multiply that by the accrued POTUS per share, divide that by 1 to the 12th, and subtract the reward debt. All right, interesting. We're not sure what the reward debt is, so we're going to have to figure that out in just a second because we haven't seen that defined, but that should be coming up here. Now, in that case, we're then going to take the pool that you're staking into. We're going to grab the LP token. We are going to do that safe transfer from. So again, this is something that is part of the definition of the LP token. This is coming from Open Zeppelin, and thus we have a reasonable surety that this is a safe operation, because this is likely not something the dev has developed. And we saw earlier If you actually want to go look at Open Zeppelin and look at their code, you could see the code in here is actually coming from there, which is good. That's a good thing. We want to see them reusing code like that. So in this case, it's going to calling that safe transfer from, and that is making sure that what it's doing is saying, all right, take the user that sent this in, and I want to transfer that from, do that safe transfer from this user into this address for that amount. So that is where it is taking the tokens you have sent in. So it's completing that operation to say, okay, I need to reach out onto the blockchain, into the system. I need to reach out to the VM and say, look, I don't have the ability to actually go monkey with people's wallet accounts and such. You need to authorize that. The way you're going to authorize that is by actually reaching out to the VM and saying, okay, you do the security to make sure that the person who sent me the message is authorized to transfer money from this wallet here. So they're trying to take it out of there. So they're saying take it out of the sender's the sender's wallet, send it to this address. So give them to this contract and do that for whatever amount they sent in. It's then going to keep track of you. So it's going to put you in there. It is going to grab the amount that it's keeping track of for you, add in the amount that you sent in. And now what it's going to do here is it's going to take the amount you have, it's going to multiply that by the accrued POTUS share and divide that by 12. All right, so that's interesting. It is now finally getting around to updating the reward debt. So to be clear, the reward debt is something that can start off at 0. So the very first time the first time you stake in, there is nothing there. You have none, therefore your amount isn't greater than 0, so it's not going to do that setting of the pending. It's just going to move straight on to this transfer. It's going to transfer, it's going to update your amount, and then updating your amount, it's going to figure out what your reward debt is. It's going to figure out your reward debt by looking at the amount that you deposited, multiplying that by the pool's accrued POTUS share, and then dividing that by 1 to the 12th. Now, what is happening there is that in setting that is establishing, well, I think, from working through this logic, actually, we had that explained up here in the code, in the comment. It says the intent, whenever a user deposits or withdraws LP tokens, here's what happens. The pool's accrued POTUS share and last reward block gets updated, receives the pending reward sent to your address. The amount gets updated and the reward debt gets updated. It is subtracting out the reward debt. It looks like I'm reasoning through why it's doing this reward debt calculation. There it is. It is attempting to, it's trying to account, I believe, for the difference of tokens that you should be awarded, as in the pending tokens. And it is attempting to account for the fact that technically, if you were to withdraw in the middle of one of these cycles, so it has not actually done this calculation and issued those rewards yet, that it would then be establishing that, okay, technically I'm marking that you should be due this, but we actually haven't reached the due date where that's occurring, and thus we are going to have to go through that. We're going to have to remove that from that point. It's kind of like saying, on where was I? Oh yes. So with that is where, as I was saying, it is going to be looking through this, and it's kind of like saying, when I'm going to give you, say, $10 every day of the week, but I'm going to give that to you on Saturday, and then you were to come by on Tuesday and say, I'd like you to give me my money now. And I'd say, well,
I was supposed to give you $10 every day, but you were supposed to get it awarded at the end of the week. Like, yeah, but could I get the money now? I'm like, well, I'm supposed to give it to you at the end of the week. So, yeah, but could you give it to me now? I'm like, well, I'm supposed to give you $10 a day, so how about I just give you $10 a day? So, we'll just say that, and this is kind of a weird way to work the math, but technically it is the most elegant way to handle this. It is establishing, all right, so I owe you, or you're going to get $70. It's like, yep. It's like, okay, would you like to get that done now, on Tuesday? Yes. So that's going to be $30. Yep. Okay, so I'm going to do the math to say that basically, up until Saturday, until the end of the week happens, when we start this point, I'm going to say, technically, you owe me $70. I'm like, what? And we're just going to keep whittling that down over time and use that to calculate how much you're due. I know, it's a little weird if you think about it like a normal person, but if you think about it like a dev, and like a computer, which isn't a person, then devs are barely human. I know I'm barely human. I'm a dog. I'm just a talking dog. Then that's where it is doing that accounting to make sure you get the right amount. So it's a little weird, looks a little odd, but technically it's correct. And then it's emitting that deposit to say, okay, whatever they sent in, boom, let's go ahead and make that happen. So they're just sending it out to the chain, out to the miner running this to say, all right, go ahead and give them their money. Cool. Everything good there in the deposit. Withdraw. Oh, God, complicated. But at least we figured out the logic. So, in this case, it is going to be going through, doing the same thing. All right, pull the pool that we're supposed to be withdrawing from, pull the user that's asking withdraw. Only do that for the user that's sending in the request, straightforward. First, make sure that the user actually has the amount that we're trying to withdraw. Good safety check. That way this thing isn't going to like blow up in some weird crazy way where I just decide to hack it and like punch in some number and then give me all the coins. It's going to update the pool by recalculating the redistribution, because some user just withdrew, so like the distribution is going to be different for everyone else now because there's fewer tokens in there. It's then going to be pending. So it's trying to figure out, okay, what is the pending amount? What would I owe, or what should I pay to this user? Again, doing that by taking the user and their amount and multiplying it by the accrued POTUS per share, dividing that by 1 to the 12th, and subtracting the user's reward debt. Basically, much the same operation we were seeing above. It's just calculating that pending. It is then doing that safe POTUS transfer. It is transferring to the user that pending amount. So it's saying, okay, this is the amount that you have not yet gotten or that you should be getting. Here you go. Or should say, yeah, it's going to be, doing the safe POTUS transfer. So now let's make sure that we understand what is happening in that safe POTUS transfer. So we got to go up. Oh my God. No, I'm doing this because I love you guys. Or maybe I love DJ. I don't know who the fuck you guys are, and I'm not sure you're my type. But the point being is, whew, man, now you see why auditors get paid big money. Partly because they can also get sued if something goes wrong. So again, remember, I'm not your financial advisor. I'm not being professionally engaged by this. No one's paying me for it. I am doing it for fun, the kicks, the lulz, the trolls, because if I do come across a scam, I am going to lay down so much verbal abuse on that guy. This one seems to be fine so far, but I'm doing it for the love. But I want to be clear here. Alright? You're not paying me. I'm not giving you advice. I'm just having fun with DeFi Degens, because I'm the DeFi Degen Doge. Alright, now, safe POTUS transfer. What is this doing? Alright, well, this thing is checking the POTUS balance to make sure that this thing has enough, and then it is actually issuing that transfer. So again, this is where it is going to be making sure that it is doing the appropriate transfer. In this case, it is... What are we doing here? We are going to POTUS. We are getting the balance of this particular address. Sorry, this one. We're trying to figure out, all right, POTUS, how many tokens do I have as the contract? It's going to hold that here in POTUS Bal. It is going to check to see, okay, is the user trying to transfer an amount that is greater than the POTUS balance? If the user is trying to ask for an amount that's greater than the POTUS balance,
then let's just go ahead and transfer them the balance. Now I want to be clear here. This should be fine because we saw earlier that the check here, this safe POTUS transfer, before that happens, it's doing this require to confirm that the user is not trying to remove that. So again, this is saying if this works out to be true, then go ahead and continue on. If this works out to be false, if they're trying to remove an amount greater than what they have, instead send back this error. Alright? So it's okay here that it's establishing that if you try to send an amount that's greater than what is actually available, it'll just give you the rest of the balance. We'll have to look at the tokenomics, see what's going on here. But because this is kind of a gamified token, because, you know, yes, there is liquidity, yes, it is gaining money, yes, you will be getting profits, technically the tokenomics around it are a little bit gamified in the sense that, you know, it's kind of tracking the election, sort of simulating some fun there, and really trying to reward people for holding. In this case, it is technically possible that it could run to the end and not quite have that little bit. Probably not really a big deal. Really, I would read this more as a safety measure so that if somehow the math ends up being like a decimal point or two off, you'll still get your reward. But I want to point out here is that technically this is going on. It is safe because we have this require, so I don't want to, it's not a bug, don't worry about it, it's not a rug pull. But I'm going to establish here that it is technically possible that when you finally leave as the last person, when you're draining out the last bit of POTUS, you technically might not get the full amount. But honestly, going through the math, I would just chalk this up as a safety measure to make sure that the last amount can't get locked. Looking through this, I can't see anywhere where the math could go wrong. But that's another weird, like an indication. I know it looks weird, but it actually is good to have it like this. This is a safety measure. So if something weird does happen near the end, if somebody got their math wrong or whatever, then the worst that happens is that you're just going to get the remainder of the reward that's available. But looking through this, I don't see a way this could really go wrong. This is just that safety mechanism. We're coming up on the end, guys. I know. So, else, just go ahead and give them the amount that they asked for, or that they're supposed to be getting. Cool. Simple enough. Most of the time, it's going to be doing this. All right? Now, that's what's going on in the withdrawal so far. So we got that safe POTUS transfer. Then it's going to say, okay, well, since they're withdrawing, go ahead and look at the user, see how many they have that we're keeping track of for them. So track the amount they want to withdraw. Do that and set that to the user's amount. Then go ahead and take the user's amount, multiply that by the accrued POTUS share divided by 1 to the 12th to figure out their reward debt. All right, there you go. And so actually, by doing this math here to try to set that reward debt in this way, it looks like I might have been a little bit wrong, where earlier it was setting and adjusting the reward debt. Over here, well, it's kind of doing the same thing, but it does look like it's attempting to account for that monthly work. Like, it's trying to work over that year. But again, we'll see that laid out in the tokenomics. So I'm deducing here from what its work is that it's trying to figure this out on a, like, per-month cycle, roughly. But it's not really running per month, it's just trying to divide it up by 12, kind of like over a year, kind of, sort of. Anyway, so again, in this case, it has this point here of the LP token, where getting the reward debt, figuring that out, LP token, safe transfer, again, it is where it's going to say, okay, we want to do a safe transfer from the pool of the LP token that it has to the address that is requesting this withdrawal, which will be the person who sent in the request, and the amount they want to withdraw, and then it issues the withdrawal again to have that take place, or to have that logged. So I want to be clear here is that technically the withdrawal is happening here on this line. This withdrawal that's happening, that is telling the system, hey, log this. This becomes part of the transaction hash. So again, good. It's creating the necessary entries in the transaction record. All right. Here we have in the emergency withdraw. It says withdraw without caring about rewards. Emergency only. Okay, I like this. I like good defensive code. It does make it long, does make it a bit more to get through because you got to account for all the possible error scenarios, but it's good to see a dev that's thinking ahead, that's seen all the terrible snafus that we've had in DeFi, and have gone through and thought of things. Okay, if something does go wrong, even though I think my code is good, even though I'm letting the DeFi degen Doge to look at my code and confirm this, I want to be sure that if something does go horribly wrong, and this fucking DeFi degen Doge is high or something, that we do have a way to get out. And that's what this looks to be doing. And we can confirm that because it's saying, look, all right, just give me an emergency withdrawal from a pool. Emergency withdrawal. All right, so go ahead and go into that pool. Go ahead and find out, who that messenger is. So get the user's information for that. Go ahead and execute a safe transfer. We just transfer out that user's information. And so it's quite literally just saying, okay, look, just have the amount that you currently have, like whatever that is. We're not figuring out the rewards beyond this point. So that, to be clear, this emergency withdrawal does mean that you would get your rewards as this thing is going along. All right? So you will have them because, as we've seen, as it's going through the various steps, it is actually accumulating your rewards bit by bit. So this is just saying that at some point, if you want to say, all right, rather than figure out what my rewards will be coming up, just give me what you have accumulated right now as an emergency measure. And it does that by going to the pool, again, transferring it out, sending them to you, and then issuing a log message for that emergency withdrawal to define who did it and what that is. And again, sets the user's amount to 0 and sets the reward debt to 0. Now, okay, so I want to be clear here. Notice, we're just sending a pool ID. We're not sending an amount. By default, this thing is just taking out your entire liquidity that you've accrued to that point. And then it's just resetting you to 0. So that, again, if there's like some sort of weird rounding error or something odd that happens in here, it's accounting for that and saying, okay, look, you truly are out. So, useful. It is public. So technically you can call this. If you call this, though, you will only be able to do it for yourself. I want to be very clear here. Whenever you see this message.sender, that is you sending in the transaction. So when we see contracts like this, where it has something like an emergency withdrawal, and we see here that it's referring to the message, we can be sure that in this method, because the message sender going in is provided as part of the Ethereum protocol, and it's only sent in as part of using the key for your wallet, the little encryption bits that's stored in your wallet that lets it engage with Ethereum and do its work. That is where we have this extra stuff being set up. And so that's where it is taking that. When you send it in, it does all the signing and certain things to say, yes, I am the approved person to be interacting with this wallet. It is then getting that, and then that way in here, there is no way for the dev or anyone else. No one else can get your liquidity in this emergency withdrawal. Only you can. So far, and I'm almost done here. We've gone through almost every single line, and we just got one last one here. So far, this contract, it has emergency methods to resolve an error, in the sense that if something goes wrong, if it is not going to behave as normally, I see no reason why it would not behave as intended. But if something does happen, because later on somebody discovers a bug in Ethereum or something that nobody's figured out by now, I don't know how it would be working if it had something like that, but whatever, then this is a way that he could try to alert everyone. So if you stake into this thing, make sure you join the Discord, alright? Join the Discord, join the Telegram, join all the goddamn social media for your projects, for fuck's sake. I hate Telegram, I hate Twitter, but still sign up with them, still get the notifications for your projects. Because that way, if something goes wrong, he can spam out a message to everyone saying, holy fucking shit, things have gone wrong, quick everyone, withdraw your liquidity. And that's it. That is the worst that could happen in this case, is if somewhere out there we do somehow end up with some weird crazy bug in Ethereum that hasn't turned up yet, that I can't possibly conceive of, that would still be there until now, or some exploit that nobody's figured out before. It looks like the worst that could happen, provided Ethereum itself doesn't turn out to be complete garbage, which honestly it's not. It wouldn't be here by now if it wasn't fine. Then the worst that could happen in all of this is you look at a notification and the dev has told you, all right, this thing has broken. There is there is no way. Sorry, this thing has broken. There is no way for us to continue on with this game. There is no way for you to get additional rewards. I don't see a way that it's really going to reduce that, because you notice it's just removing your debt. Your debt can never be more than what you have, so it can't really run out of control and lose. It can't really run out of control and lose your stake or anything. The most that could happen is that the thing just kind of craps out, stops paying out, and the dev tells you, sorry guys, I don't know what the hell happened. Ethereum must be broken, so go get your liquidity, game's over. It can't really lose anything. And like I said, the only way that's going to happen is, one, if you call this thing and do this yourself, in which case, why would you ever do that? Like, just leave it and go through the normal process. Or, like, something has gone horribly wrong and the dev tells you to go do it. And that's very likely what they would do, is have an operation. They change the site, they provide this emergency withdrawal button. And you can also do this yourself. Technically, you can go into Etherscan, just send out that request yourself if you really wanted to, if you connect your wallet to Etherscan, all right? So, last method is where we've got dev. Update dev address to the previous address. This is where you send in an address. It is going to look at the sender. It's going to make sure that, okay, the sender is the current dev address. If it is, then if it says, all right, if this is true, so as in the sender is the dev address, if that's the same, then what are you doing? Like, what? Why? On the other hand, this is establishing that if this is not the same, then we can continue on. And so it will be establishing, all right, if this is true, send that. If this is not true, if we're not setting to the same, then it's going to be able to modify that. So whoever the last dev was, this is a way for the developer to hand that over. Now, this method here, different frameworks have different ways to handle it. Personally, I kind of like the way Solidity handles it with their owned interface and how they can have that method to change ownership. But again, main point here is it's just trying to set that dev address, and thus this is where it can change ownership. So, as it stands right now, I would have to say that the contract works. I don't see any bugs. I don't see any problems. I don't see anywhere where this thing can go really wrong. We have our ownable contract. We have in here that method, that definition of trying to set the message sender, the one who actually sent it in. We're establishing that whoever sent in the request to construct this thing becomes the owner. Emit that ownership transfer record to say, all right, the system no longer owns this. The person that deployed the code owns this. We have ways to get the owner, and then the modifier here, this is anywhere that we saw only owner, this is that verification that it's going to do that check. And also gives a way for the contract or the owner to renounce ownership. It can only be called by the owner, but they can call that in, and that sends it off and sets it to the system address. So technically this has a way to burn it, but as you can see, there's some things in here that the dev has these emergency escape hatches that can be used, so we kind of want them to hold on to it. And they've said they're going to be doing a multi-sig wallet to manage that access with other prominent key developers that will be assisting with this. So hopefully we can trust them, hopefully they are good guys, and hopefully none of them get hit by a fucking bus. Alright, to confirm, we've got message from our God Emperor at 8:30 p.m. Pacific time that the sale is going to go live in about roughly about 12 hours. It's going to come up as 4 p.m. CEST. Oh god, that's Europe. Yeah, that's Central Europe. Alright, so 4 p.m. CEST, the first round will start. It'll be 1,000 POTUS per ETH. That will last 1 hour, so it'll end at 5 p.m. GMT. Huh. I think that might need to be checked on the time there. Pretty sure that's a typo. In this case, anything unsold in that first round is going to be burned. Second round, there will be... Alright, there will be 200,000 POTUS at the price of... Oh, that's cute. 444.444
4444444. Cute. POTUS to 1 ETH. Then the second round will last 12 hours from 6 a.m. CEST. Yep, and everything else will be burned once that finishes. And we can see that there will be a update on the site. In fact, we might be able to see that if we refresh. But he says there will be a timer on the site in the round 2 countdown that will provide that information. So, looks like that link has not gone live yet. He has provided the link in his Discord. So, we'll just double check to see if there's technically anything there yet. Because, you know what? I am a DeFi degen Doge. As far as I'm concerned, once it's online, it's fair game. If you didn't want me to look at it and poke it, you wouldn't have let me touch it. Or you wouldn't have posted it out there. So, bam, we've got here time and date. This is doing a check where it is counting down. So to be clear here, this is not something they wrote. This is not something they put together. They gave us a URL. Looks like this is a redirect from the president.finance site over to the time and date website, which if you pass in the right, request parameters and the, path variables. No, sorry, that is request parameters, sorry. Yeah, if you pass in the right request parameters for the this site, it'll do a calculation on how long until then. So here we go, that 12 hours. Based on Paris time. Cool, Paris. Maybe we're dealing with a French guy. Awesome. If you're French, I'm very sorry you have to deal with Macron. If you're not French, I understand. There's countries kind of all along that time zone. All right, now, we have gone through the code. The code seems sound from my guess. Again, for my own liability and to set your expectations, I am not doing this professionally. I am not compensated by the team. This is not an official bonded audit. I am just a DeFi degen lover. I am wanting to make sure that people are able to make good, educated decisions on their risks. So far as I can tell, this contract looks good. It looks solid in the sense that it will function. There are some emergency release valves in there, so the dev can do some things, like they can drag a halt to this, they can force updates and modifications or resets to how the award is being calculated. But as we saw in here, there is not a way in the code for the developer to actually get anyone's liquidity out. The most they can do is add in a pool, and if they try to add in a pool that already exists, then there might be a problem there. This is where I might have put a defensive check in here, so that if you tried to add in a pool that already exists, that it would just error out and say, yeah, I can't do that, and I didn't even try doing it. But I can see the intent of leaving this here, because if something does go absolutely horribly wrong on like the first launch and it's fucked up, then the dev would have the ability to fix that by just deploying on top of it again and trying to erase that and manage it. So again, not likely something that's happened, but I'm just pointing out here, one risk is that in here, because we didn't see a entry here of, well, a check to absolutely totally confirm that the pool doesn't already exist. If the dev does do something stupid and they do try to add a liquidity pool that already exists by sending in that token, then technically the rewards could be messed up. All right? Now, to be clear, the reason the rewards would be messed up is not because it's having an issue of like overwriting or something. It's because all it's doing is adding the new pool to the end of the list. Now, I might have accounted for this, in this case, by actually using that map operation. Because again, the map operation that we saw earlier, where did we put that? Where was that? You know what? Let's find that here.
That's checking the greater than. That's checking that. Ah, yes, here we are. Mapping. Thank you. Alright, so, in this case, with the mapping, this is where I might have addressed this by actually making the pool info a mapping of that information. See, that's kind of what's happened here with the user info. The user info is actually a relationship to, or a collection, a key value pair it's called, of address to user info. That's technically how it's working, is that what it's storing kind of like an index. It's saying, all right, I want to store this user info, but I don't want to keep track of the user info in some way. I'm not, like, I need to be able to distinguish between them. And so rather than try to keep track of the order or something silly like that, it's saying, look, I don't really have a way to keep track or identify these individually to make it easy to retrieve a specific user. So in the mapping, we're telling this in the code, I'd like you to store this user info, but I'd like you to store it under this key. So I can come to user info and I can say, hey, user info, I'm going to give you a number. You're going to take that number and you're going to use it as an address. And in using it as an address, you're going to use that to identify the particular user info object or instance, the thing that we talked about up here that keeps track of your amount and reward debt, by pulling that out. So, in this case, I might have done something similar with the pool info. I might have made the pool info actually like another mapping. I probably would have had it be a mapping of pool. Basically, to be honest, I probably would have done exactly the same thing that I have here. I would have just said that it's just going to be a uint to an uint or a uint to an ERC token. Actually, probably not that ERC token, because then you'd be burning it. But it would be some address of the token that's going in there. And so that way, yes, we would be working with real tokens and adding them, but I would be able to pull the pool out by actually telling it, okay, well, actually I want to update this particular pool where I have that. Now, I'll have to double check exactly what is happening within Open Zeppelin and Solidity and all that stuff to be absolutely sure. It's been a while since I had to write one of these. If I recall correctly, like most languages that have these map operations, these key value pairs, technically you can reach in and say, okay, just give me that list of values or give me that list of keys and let me iterate over them. So you could have simplified that by having that key and then still be able to do all you need and still have the operation to iterate through things. But I can kind of see what they're going for, and on top of that, having the maps, that's a costly operation. There's a few points in here where I might have like pointed out ways this could be optimized, in the sense that everything the contract has to do contributes to the processing power, the resources, the time that it takes to do it. And so there's a few points in here I might have optimized this so that it doesn't cost as much to run. But it's not a big one. There's not like any glaring inefficiencies in here. There isn't a way that I could have really tightened this up. I probably would have, like, there are a few things that maybe you could have done a few things and like shaved, you know, a few single digits or low double digits, like 10 GUI off the transaction fee, maybe like 20 GUI. So not really that much. At most. But again, just a point there. I'm just calling out some points of it looks like a costly contract to run, not the most costly, it's not terribly expensive, it's within reason for what it's doing, and one optimization point on managing the pool info. Otherwise, solid code, it'll work fine. There's no bugs. There are emergency hatches. The emergency hatches do not give the dev any way to steal the funds in here. They can't take it. All they can do is update the liquidity pool by adding more in. So like if this goes really well and I was like, let's do it again for the World Series or some shit, or the next election or whatever, they could technically come in and add more. You know, if another candidate comes out of nowhere, they could technically add that in. But it's not exactly that it's going to ruin the rewards. You're just going to get this weird case that if they do that with a pool that's already in there, you're going to have two instances of the pool, which means as it's running through and operating, it's going to be updating two instances of the same pool. So it's going to be keeping track of two separate sets of liquidity pool tokens, but technically on the same one. And because when trying to do that, it's going to go in and find that particular reward. Like it's showing you the pending reward that you're due based on you, not based on what's in the pool. So nowhere in here does it really have to go get a particular pool. It's mostly just iterating through them and setting that up. And so, like, when you deposit here and you're going through that, it's going into the pool, it's getting the LP token, and it's pulling that out. Well, in this case, it's pulling that out based on the pool ID. And so this is another possible potential for an error. Again, I want to be clear here is that it's technically not a bug in the code, meaning that if you interact with this thing properly, as intended, nothing can go wrong. But if, for example, someone were to send in this deposit request, and because it is basing on the deposit, which pool you're going to deposit into, that does mean that it's not actually aware, technically, of which pool that is, because it's basing it on the order that it's in the list. So, you know, like in a list, like we've got here, you know, there's these entries here on this list, and so they're in this order. You know, we've got Yang Gang, Sanders, Elizabeth Warren, Bloomberg, and Kanye West. All right, so we've got 5 entries here, and we're going through this list. Well, that's what's happening here with these arrays, these square braces. And so when we're doing things like saying, oh, I want you to go to pool info, and I want you to retrieve PID. Oh, there we are. And I want you to deposit or withdraw this PID. The PID is referring to the pool ID. It's, again, just something the developer made up, but it's saying you're supposed to call this by passing in the pool ID, and in passing in the pool ID, it will go in, retrieve that from the array, and do the work. Now, that is an optimization in the sense that it is less costly for the miners to execute this, therefore it won't cost as much gas. The way I was suggesting before of keeping track of this with a mapping would actually take a bit more gas because mappings take more work to operate with. They're bigger, they're heavier, they're more complex objects and operations. So, in this case, technically, when you do a deposit, you're not actually depositing based on the token you're placing in. Technically, you're depositing based on which pool ID you're identifying you want to deposit into. And because the pool has this LP token, as we saw up here in the pool info, gives you this LP token here, and it's that instance of the token. All right, it's got one. This isn't a collection of them. It's just being told what that is. All right? And so because it is, here we are, because it is going and getting the LP token and then doing that safe transfer from, and it is doing that, transfer it from your address into the wallet or the contract itself, and when we go look at safe transfer from, Oh, pardon, I shrunk it, that's why. There we go. Alright, so, with the safe transfer from, there we are. In here, in being expanded, we can see that it's call optional return, it's going through here, it's taking the token, it's saying that it wants to token transfer from selector, and so it's going through and in this case, call optional return. What is the call optional return doing in this case? Because I don't want to say it's a giant bug. I'm kind of working through that process here. So, safe transfer, we're passing the token, address that it goes from, address it goes to, and the amount. And so now we have this call optional from, and in the call optional from, where'd that go? What do we have here? Another call. Ah, here we are. So, yep, here it is. Call optional from. It's doing this check to see Okay, yeah, it's looking at or it's building out an address. So it's saying, okay, look, I want to interact with this token ID as if it were an address. So actually tell me the address for the token. So it's converting into an address object with that. Perfectly normal, appropriate in the call. And then saying, okay, function call data. And so it's passing in the data that it got from the call optional return. And it's actually confirming whether or not this is safe or not to execute. From there, it's just doing this check to say, okay, is all of this data actually valuable? Does it actually work? It's doing this in this decode to say, all right, go to the API, decode, actually confirm this is correct. And so it's doing a safety check to make sure that entries aren't invalid. But as we can see here, it technically isn't doing a check to see if you're still interacting with the same token. So, technically, in the deposit, if you fuck it up and you deliberately go interact with this thing in a stupid way, or if on the website the wrong PID is being sent in, then when you go through, the amount of tokens you deposit will be credited, will be deposited successfully, but the amount that you deposit actually goes into whatever pool is identified here by passing the PID. So that's where, if we really, really want to get froggy about this, we're going to need to look at some of the source code for the site. Which one is that? Yep, there it is. F12. Oh, God. You see what it takes to, like, to audit a contract, boys? Like, this is not a small thing. Alright, so we're going to have to go look into the contract, or the site itself, and we're going to have to see how this is put together. And in seeing how it is put together, we would have to dig through and start finding... Oh God, we just start digging through this and confirming where some of those actually are. Now, I want to highlight here that this is... Okay, we got Webpack. Webpack is generally useful. Oh God, this is times when I wish I had the dev on to tell me, oh, go look over here, so I don't have to find all this shit all the time. Alright, so that's StackPath, unplug.com, we've got our Web3 call, we've got our structure in the project here, we've got our index in the source, and we've got our Google Analytics, Google EDA Manager. Alright, so all this up here is... here we are. This is where we've got some of our actual code. And there is where our JavaScript is. Okay, POTUS.javascript. Okay. Here we fucking go. Now I think I've got that goddamn point here. Oh, which one we're dealing with. Alright, so, which one are we fucking dealing with here? Alright, we are handling... There's our prices in this case. Sorry, can I zoom this? No, I apologize. I don't think I have... Oh, wait, no. Oh God, I hate that. Okay, I'll undo that in a moment here. But, alright, so, to make that bigger for you guys, this is the source code of the website. God damn. Alright, so, in the source code of the website, we can see here that it has identified the pools. It is keeping track of the old pools. Excuse me. It is keeping track of the new pools. Here in this Uniswap ABI, this is information that it has on how to interact with the contract. Basically, this is the definition of all the various methods and what needs to be sent in. Down here, we have where it is doing some of the various math. And it'll be clear here, the math that it's doing is... Yeah, in this case, it is trying to interact with the contract. It's doing that through ABI. It's doing that by sending in the pools. Pools are a multi-dimensional array. And in Working and sending in the pools by accessing the particular entry. Where is... Yeah. Alright, so it looks like... Yeah, it is doing some calculation here to be able to show you things and show what's up there. And to be able to show the entered amount. But yes, it does look like in here it is, and don't worry about this, it's just more commented out code. This is probably some portion that had, yeah, it looks like it was an old version that they made some modifications to and took some points out. So, like for example, the total liquidity entry and other points, and the VAR percentage. Alright, anyway, so in here, yeah, it looks like when they're going through this that, yes, it looks like they are just passing in the numerical ID of the pool itself, and thus, yeah, yep, thus when they are doing that work and sending in and trying to update a pool, the website is telling the contract which one it is trying to update. So it looks like it's fine now, it is all in place, but technically which pool you're being deposited into is controlled by the website. It is managed by the entries of pools up here that it's keeping track of. So this way it can, you know, essentially the list of pools here should match the list of pools in there. But if somehow this gets out of whack, then when that occurs, and good, thank God that the owner is the only one that can deposit a liquidity pool, otherwise someone could come in and fuck this whole thing up. But in this case, technically there is that risk that if somehow a deposit occurs and somebody sends in the wrong ID, the contract will get your tokens properly, but it will update the prize, the award, for the wrong pool, and it will... yeah, it will still update your amount for whatever you sent in. But it's going to do that based on whatever pool you told it to. So, actually, that's something I could see as a problem there, technically. I'm going to want to talk to the dev on this one, but I think, and now that I am working through this issue here, I'm going to say that I want to double check on exactly how this is working, talk with the dev. I would say ask him, and he's available. Don't want to say that it's a giant fucking problem. Oh wait, we got a message from the dev. Yes. Yep, they agree. It's from a UI fork. Haven't set up the code fully yet. The POTUS.js has old pools. So, our God Emperor has told us that they are aware of this. They are going to be accounting for it in that they should be checking the PIDs match, but they're going to be confirming as they update the site that is in there. So, I'm going to throw out there that technically this thing has a weird potential vulnerability, as I can read it, where if somehow someone were to manually interact with the contract, which you could do through something like My Ether Wallet, or you could do through Etherscan, you could, in theory, send in an amount to, and claim that you want it to go to a different liquidity pool. You're going to be like, I'm going to send in POTUS, I'm going to send in the tokens for Biden, but I'm going to say that they're for POTUS pool. Now what's going to happen here, if that occurs, where you say, I'm sending in Biden, but I'm going to say it's for POTUS, then when that's going through, it's going to be, alright, I'm going to get the POTUS pool, I'm going to get the user info for POTUS pool, I'm going to go through the user amount, for that POTUS pool, and I'm going to add in the... I'm going to add in the amount here for that, and it is... So yeah, the contract will get your tokens correctly, because that's what the safe transfer does. It will accumulate your amount based on what you sent in, but it will accumulate your amount for the pool that you told it that you wanted to update. So you could technically send in... Yeah, let me double check this, because I want to be absolutely sure before I try to say something like that. I mean, I hate to try to say I found a bug, but I want to be absolutely sure and honest here. I hate to give bad news like this, but okay, we've got our update pool. We have our user info. User info has amount, it has the reward debt, and we can confirm that in the user info, it is being tracked by the ID, which gets turned to an address, which holds the user info. So, when you're going through the deposit for the update pool, for the deposit here, it is going through and, yep, in the user info, it is saying, okay, get me the user info for this. That's the 2 calls here to the mapping that it has up here. This is why it has a mapping into a mapping right here. Saying, all right, first you're going to send in a number, and that number is instead going to get you a mapping of address to user info. You're then going to give me the address, and then I'm going to give you the user info object up here. And so in doing that, it is, in this case, it is saying, all right, give me the user for that pool, the one you told me you want to update. Get me the user that sent in the request. So I got the pool that they claim that they want to update. I got the user that they claim they want to update. I'm then going to go update the pool, so recalculate the awards for the pool that they claim that they want to update. And then I am going to go to the pool that they asked me to update. I'm going to transfer from that user, because they've authorized that, to this contract the amount of tokens that they have sent in. Now, in this case, by doing it through the message and this, understand that from the pool... No! I think I see how this is not exactly a bug. So, I want to rescind my analysis here. I have the correction. I want to be clear here. I have discovered a way you can get an error that will cost you gas, but not an error that will cause a problem in the pool. Again, thank you for working with me on it as I work it through. As you can see, you gotta think through the logic on the things. You gotta double check the lines of code, and that's why these things take so fucking long. Like, imagine if I had like a $5 million lawsuit on the line if I got this wrong, okay? There's a reason auditing companies take so long to get this done. So, in this case, what would happen in this instance as I see it is that, yes, you would be getting the pool, you'd be getting the token. Whoops. Yeah, you'd be going to the pool, you say, okay, give me a reference to the token this pool represents. I then want to ask this token, hey, could you transfer from the user that has authorized that transfer this to you, this contract, the amount here. And unfortunately, when that happens, what it's going to receive in that amount, because it's asking the LP token to do that, the safe transfer, because what's actually, no, safe transfer, as you saw, is just kind of doing a thing on its own. Like, it's going in there. Yeah, here it is. It's doing that check and it's doing this call optional. Now, in this case, when it's doing encode with selector, the token here, this is where it's doing that security check. Not exactly a security check, but it's confirming that you actually sent in the appropriate token. Okay? So, in this case, I want to confirm, this is not a bug. It is not going to break the contract. It is a user dangerous implementation that if a user, one of you guys, decides to misbehave and come in and fuck around with POTUS, you can fuck around and try to see and find out what happens. And if you fuck around with POTUS by making the call to deposit, and you try to game it by passing in the wrong pool ID, and you figure that out by looking in the code and seeing what the pool ID is from the JavaScript, then when you go through that entire process, all you will have achieved in doing is making the contract actually do some work. Namely, it will actually have pulled the pool. It will actually, for the one you request, it will have actually pulled your balance for that pool as you requested. It will then update the pool that you requested. And as we saw from the update pool operation, it does a check to see whether or not it's already been awarded this block. So, it will attempt to, but if it's already been awarded this block, it's not going to bother. If it hasn't awarded this block, it will go ahead and go through its award process. Now, in having done that, it will then go through and try to transfer the token. At this point, because the safe transfer from has a check where it's actually going through the specification of the interaction and saying, look, we're getting the token, then we're asking the token to transfer a one of itself, one of its own in the amount to here, it will be able to identify in that pass to say, wait a minute, you're trying to transfer that around. Like, this isn't necessarily the right one. So you're trying to say, do this, here is this amount, you are getting that amount in that case, but it doesn't look like we're passing the token back and forth. What we're doing, because technically we don't have the tokens, what we have is a balance on the balance for this on that token is saved. So what you're doing is you say, hey, here's an amount, I want you to go hit another ID. You're technically not passing in the token. The token is in your wallet and you're authorizing the transfer from that. So in this case, because we're not technically transferring the token, if you try to fuck around with this, try to screw with POTUS, and manipulate the deposit, like the Federal Reserve, then what you're going to get is a giant fucking error where this thing either attempts to transfer the amount out of the pool that you told it to, and it's not properly checking whether or not that's actually the pool that you should be interacting with, like for the amount that you're sending in, but it kind of doesn't fucking matter. Because the token that's getting transferred is based on the pool ID that you send in. If you see what I'm saying here. I mean, by all means, drop me a question if you think it doesn't make sense. But this is where you said, or this is what I'm saying is, because you're saying, hey, I want to transfer tokens to or from this pool ID, go get the first pool on the list and do that, the thing goes through and goes, okay, well, I'm going to try to do that. And because in here, you're not telling it what token you want to transfer, it's figuring out what token you want to transfer by looking at the token that the pool stores, then the most you can do is fuck around with this thing, try to manually put in an ID. This thing would attempt to go do that, and it would just do what you told it to. And kind of doesn't give a shit. So again, to be clear here, is the worst that could happen is there's a bug in the website, and if the website has this bug, then you could, in theory, click the button and it could go to the wrong place. Now, I bring that up as a hypothetical, but we have reviewed the JavaScript. It looks to be fine. It holds old entries, but those will be updated as this thing goes live and they settle on them. And so overall, I would just recommend, if I am not here with the actual launch of this thing, just have someone you know that knows JavaScript, take a look at that code and confirm. Or the dev is listening right now, our Lord and Master, our executive officer, our fine and orange leader, will just make it clear, no motherfuckers, I did actually double check that. Here's the screenshot of how that matches up. Don't worry about it. At which point, then, you have nothing to worry about. If you do try to fuck with POTUS, you'll just end up manipulating the pool that you told it to manipulate. There's no chance that it's going to go wrong there. Okay, so thank you for bearing with me. I'm sorry that took a little bit longer. I wanted to be clear on what is going on there. No, there is no bug. It is merely a weird interaction that technically, if you want to go do it yourself, you could just pick whatever pool you want to update. But because it's doing it based on your balance and it's doing those checks, if you don't have any funds in that pool that you tell it to go manipulate, there's nothing for it to do. So, just a kind of odd, slightly, I think, inefficient implementation. I probably would have put a check right at the beginning for that token to say, all right, which one are you trying to manipulate? Okay, that's not the one that you're trying to give me. But that's not absolutely necessary. There are several ways to handle it, and this is sound. Like I said, the worst that would happen is somebody comes in, they try to game the system, fuck with it by I'm going to send in some weird value. They're going to send in something that's not valid, like, hey, go update pool 3067, and this thing will come back with just some error out of this, like, no, that one, I don't have that many. Or you'll be, haha, I will play a system and I will say update this pool and send in this amount and I want it to be that token. And like right here is like, well, you're not telling me which fucking token you want to transfer. You're authorizing me for that. So if you really try to fuck with this system, you really do try to send in an authorization for a different token than what the pool pulls out, because you really go through the work and build out your own transaction, and you actually do say in the message, I'm going to authorize you to send in the Biden liquidity pool tokens, but I want you to send them to the POTUS liquidity pool, then part of the work of what's happening in this safe transfer from is it'll go into that and be like, that's not one of me. I don't know what you just asked me to do. I'm not that. I can't do that. I don't know what I'm doing with that, and I don't have the authorization to do anything with that. So, again, the worst that would happen is you really do go through the work of completely building your own transaction manually with some sort of tool or something, or with some sort of tool or something, not just clicking the button. You're going to have to go through a bit of work to get this done. Then technically you could try to send in an authorized transaction for a token that is different from the token in the pool. The worst that would happen is that it would, if it hasn't already awarded that block, it'll go ahead and award that block. Then it'll send you back an error saying that the token can't manipulate another token. You have to tell it to work on itself. It can't work on another token it's not authorized to work on. And you will have spent some gas and really accomplished nothing other than deciding that blocks will be distributed this reward. So technically, if you want to spend gas, you can force the reward. But because the pool is being updated every time somebody draws or deposits or withdraws, and it's only being done once per block, you're not really achieving anything beneficial to yourself, because you would have had the same thing happen if you had tried to withdraw, or if you had tried to deposit. So if you try to game this, really the only thing you could do is to try to say, I want you to update the pool without actually receiving a deposit, and you, like, maybe this thing just hasn't been interacted with for a long time, we'd like it to update that. But as we saw in update pool, it's accounting for this thing not being interacted with for a long period of time, and thus saying, oh, it's time for me to update my pool. Well, I'm supposed to update an allotment per block, and holy shit, it's been a lot of blocks since last time I updated. I'll go ahead and do that big update all at once. So, one, thank you, President, for responding as you're listening. Thank you, President, for letting me know and hearing me out on that. You do acknowledge, oh, fuck you, Corel. God damn, in Magix. I'm going to need to install that. Alright, so, as it were, thank you for being understanding. Thank you for taking my modest criticism in stride. Your feedback is appropriate, where you did acknowledge that, yes, that would be an optimization, but your patience in hearing me out and describing the intent, and as I work through it again, yes, I can go back to confirm, and I'm sorry it's back and forth, but that's how these things fucking go. Normally you don't hear about the conversations we have in the offices, alright? Normally you don't hear some guy walking across the office to someone else and going like, I think I found a fucking bug here, what do you think? And it's going through this whole thing. So, in this case, no, it's not a bug, it's just a little weird. The worst that would happen is you'd spend gas, force an update to the rewards that would have happened anyway if anyone interacted with it, so you're not achieving anything, and you'll just spend gas on an error. So, thank you for your patience, everyone. I appreciate that. This is solid. Like I said, man, a little rough, but to be honest, it's tough to get good, clean, elegant solutions in code. Sometimes whatever it is you're trying to do just doesn't work out terribly well. And this thing's being a little weird and offbeat, so yeah. I can predict from, without even quite looking at the tokenomics yet, or without having gone through that review of the tokenomics just yet, this thing is clearly incentivizing holders. It is incentivizing early adopters, and it is incentivizing holders. So, I would seriously recommend that in this case, get in early, get in big, go ahead and deposit into the double reward pools if you really like, but keep in mind you're going to be getting POTUS tokens out of most of these. If you would like to invest others here, like the DAI, ETH, and such, you can, But if you want to get POTUS tokens, you're going to get double. And so in this case, you can either get a reward, or you can get a bunch of POTUS tokens. Or sorry, cash reward or a bunch of POTUS tokens. So in this case, yeah. So in that work of getting paid out in the very POTUS pool, or I should say not having to have POTUS to put in and then getting paid out in POTUS. So if you don't have any POTUS, you can come in, buy in with something else, get your POTUS. If you're able to get POTUS, then you can buy in with the POTUS and get a better return. So, on that point, I would say, get in early, get your POTUS early, stake them. If you can buy POTUS, actually stake them into the double rewards pools, unless for some reason you actually like McAfee, whatever. And then let it ride. The longer it sits there, the more reward you'll get. There's no reason to withdraw. Maybe the most you do is if you have to start off with one of these others, maybe collect your POTUS and then move over to one of those. I'd have to do a bunch of math to try to figure out at what point that would actually turn out to be like the right point to do that, and it will all depend on gas fees. There is a calculation on the reward distribution and how this is being broken out, but we went through that, worked through the math. And so really, the tokenomics as laid out here just gives a human readable plain English explanation of what the fuck I went through in looking through all the code. So, my god, that took a while. So, President, you've been a good sport. Thank you very much for being open to getting this live audit. Guys, I appreciate you being involved and hanging around and being patient with me as I listened through it. I know some of you wandered off. And I appreciate your patience as I went back and forth and tried to work out exactly what was happening. But I want to make sure I gave you guys a good answer. Again, I am not a financial advisor. I am not professionally engaged to do this. This is not a professional recommendation. I'm not actually liable for any of this. I'm a fucking dog on the internet. I don't know why you're listening to me. But, as a DeFi degen Doge, I can tell you that, it looks like a decent contract. It's solid. There's no real bugs. There could be some optimizations, but to be honest, for what they're trying to do, there's really not that much of a better way to do it, and the safety measures that I put in would actually make this the safety measures that I would recommend would actually make this a fairly more costly contract to even run. So, we'd want to avoid that, hence, I can see reason for doing things this way. It makes it a cheaper thing to interact with. So, with that, man, it has been a while. I am tired, guys. I am sorry that it has gone on so long, but I do have something I need to get to. I will have to leave it at that. Hopefully, I will see you around. Like, subscribe, share the link. You can find me as Coyote on Discord. You can find me within the POTUS.finance. I'm going to be just in there for a while. I don't tend to leave servers for a long time until I absolutely have to, and then I just leave the oldest one at the bottom of the list. So I'll be there if you need to find me. Feel free to @me if you need anything. I am, again, not affiliated with the team, not compensated by them. Nobody is paying me directly for this, so I am a completely impartial judge. I am not bought in on this project, and to assure my impartiality, I am not buying into this project. That is the only legal assertion that I will actually make. I own no POTUS, and I will buy no POTUS. That is not because I don't want to profit. That's not because I don't think it's good. This is a good contract. It's solid. There's no real bugs. There's no vulnerabilities, no errors. Everything will work as intended as far as I can see. The tokenomics do make sense. It will award. There is no chance of losing out because this thing is minting more tokens to award out as needed. The mint process is secure and reliable, so it's not going to spin out of control like some of the others. Other than that, the only reason I'm not buying in is, to be honest, I really want to make sure that I can give you guys good, trustworthy, reliable, impartial audits of code. That's why I'm not auditing projects that I am invested in. If you'd like to see my experimentation wallet that I have recently for starting this, or if you would like to offer me a tip, feel free. It is coyote.eth, CYOTEE.eth, ETH. You'll find that in the channel description. And otherwise, have a good night. Enjoy your coin. It's a fun little meme coin with decent tokenomics. No real plan yet on what to do with POTUS after this, but
the way this thing operates, at that point, it's just money. So it's just money that you can have and spend if people want it. Who knows what it'll be worth. But I would definitely say in this case, unless there's a plan for a POTUS ecosystem, then yeah, get in, get your rewards, get your earnings, and cash out quick on that one. Once this thing is done, then there's really no point to continue. Otherwise, you just sit and earn. And as far as I can tell, for the most part, this thing is pretty much just gonna run. That's where it is. The main intention here for the profit scheme after that is that on election day, the liquidity is going to get transferred over to the finance contracts. So yeah, a ecosystem is going to get moved over there. The liquidity will move into that ecosystem. They will continue working on that. That's where they will transfer over the Uniswap liquidity pool tokens and redeeming them in Uniswap. And then we'll be initializing the liquidity pool pairs with those tokens. And then the new ones will be much like the Uniswap pool tokens, and from there the fees will be distributed out to the POTUS token holders. So in the end, POTUS will be a way to redeem, but that is what I'm saying is get in, get staked, get your POTUS, and then judge what those investment schemes are going to be and decide whether or not you sell there or continue on by redeeming those rewards. It definitely looks like this thing is intending to run for a while, and other than, yeah, that last 60 days, you know, that end there, that's just the end of the rewards program. So get your tokens, get them in, get them staked, leave them to the end, the very, 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 very end. Then get them out, and once the rest of the ecosystem launches, there should be rewards to recover. Your call on redeeming those or trying to sell them off and have someone else redeem them, we will have to get into at that point whether or not that system's going to burn the POTUS tokens, or whether or not they are going to get back what is in circulation and be able to reuse that. Not a problem if they do either. I can see merit in a system buying back the tokens and then being able to do another round like this with a whole set of the existing tokens. I could also see benefit in them, yeah, actually burning the tokens. So once you redeem, it's burned. I'll just point out that if they start burning the tokens, then this project would wind down as people collect liquidity. And the last person that collects liquidity would effectively end the project. But that's like I said, absolutely every single person in the team, on the project, every single holder would have to start cashing out if they burn. If they just buy back and hold on to the tokens and then never mint anymore, or if they continue using the mint operation in future ones, so be it. But in this case, they can't just mint more tokens. That's locked up in the contract. There's no way for anyone except the owner to call. Actually, there's no way for anyone to call that, because the only way to get it called is to go through the reward process. So, yeah, we're good. So, again, thank you very much, everyone. I appreciate you sitting through it. Our God Emperor is, and Lord and Savior, President Trump here, is absolutely fantastic. He's been a great sport, very humoring and hearing me out, very relaxed. I'm sure this was very stressful as I spent several hours talking about this, and he's wondering what is this fucking dickhead with a dog avatar going to say? So, fun all around, guys. I hope you enjoyed it. Otherwise,